Hello. Can you guys hear me?
Yes. Oh gosh, this is already going live.
Yes.
Okay, so this is a bit tricky then to test polling.
And I'm going to make you co-host.
Yeah. Yeah, right. I am a co-host now, but I do not see the poll symbol, which makes me wonder whether that's a host thing.
No, because I'm with the host user in the VM and it doesn't have it, so it's not configured.
What? Okay.
Let me go to my meetings, webinar. This
Can I
is.
share the ad with you in the meantime?
Give me a let me finish with it
Yeah,
and I
yeah.
can. Polls. I think so you can create a poll here.
Yeah, but I don't see the poll button. Like I see participants QA share screen, polls. I no longer see the poll button. Do you see the poll button?
I don't, but I think the way to do that is in the Zoom page, in the Zoom web page.
Okay.
You can add one. I can do a test if you want.
Okay, so I go to the web portal, right?
I'm doing a test just to see if it works.
Yeah. I'm not doing anything. I'm just checking.
So I created a test poll.
Okay, I see the poll. I see the poll button now.
Okay. So
yeah.
can you start it?
Launch polling, right?
Yeah.
And I say allow panelists to vote.
Yeah.
Okay.
Yeah. Okay.
Yeah.
It works.
Okay. So how do I do that?
So what I did is I went in the Zoom with the Zoom admin account. You need to edit the webinar, and there is a poll at the bottom.
Okay. Yeah, I'll try that.
And you can remove the one I did, right? So.
Relaunch polling. Panelists relaunch will clear.
I will send you a.
Ooh, end polling. Okay.
I will send you a screenshot where I did it, so you find it.
Relaunch polling.
Okay, so I will continue with because I need to boot all the ads.
Yeah. Go. Thank you.
So, no, you're welcome. So Jan, you were asking me for help. What do you want me to do?
I wanted to log into the VM and play the ad actually.
Okay, so give me a minute. I'm going to configure the VM for this room. I didn't yet, so I need to SSH. So we are in. This is knee, so I'm going to need to find knee here. Knee. This is Zoom webinar 3, okay? This is SSH.
Wait, should I log in with the Zoom webinar account or
with
something?
with the admin.
I don't. Wait, what? I don't think I was given the admin one. What was I?
Okay. Let me check.
Okay, like
I can tell you which one because I'm logged in there. So is the where is my account?
oh, that's in the control room, right?
Yeah, but let me go to profile. It's EuroPython Zoom admin.
Okay.
So the other way to do it is using the VM, right?
Okay, so that is actually the email is indeed the Zoom webinar one. Yeah. Okay.
Okay.
Yeah, so I got that. So did you send me the screenshot?
I think I didn't in Telegram.
Oh, in Telegram. Okay, cool.
Sorry. Yeah.
No, it's okay.
So this is Zoom Winner 3.
Okay. Are you still seeing the current poll now, or have I ended it successfully?
No, you ended.
Okay.
Because it's a different Windows, right? It appears a different window in your computer.
Okay.
So here we have, I'm going to play ads here, okay? So because I want to test it.
Okay, that looks fine.
Είμαι η Μαριάννα. Λάτρεψα την Python από την πρώτη ματιά. Αυτό είναι που με έκανε να ασχοληθώ με την κοινότητα του Python Guild στην Bloomberg, στην οποία πλέον είμαι επικεφαλής μαζί με τον Μάτο Βοσνίσκι.
What language was that?
I thought that wasn't that Spanish?
No. Oh, maybe Catalan.
That looks good, yeah. Can I launch the poll just to see whether that works?
Yes.
Okay.
You can.
Okay, so I found
Yeah.
out. Yeah. I
You
found
can
out.
log in to the using VNC to the NI VM.
Yeah, but I don't have my SSH keys there.
Okay. Send me your SSH key and I can add it. I'm not seeing the pool, Raquel.
Yeah, it says, what about now? No, okay. What did I do? So I just saved it, but
Maybe you need to reload or something.
okay. Yeah, I really don't understand this. My case. So after you added the poll there, you basically would it just launch automatically, or?
I just clicked save and you told me that you were seeing it. So
Right. Okay.
That's all I did. So yeah, and I'm going to add your key to this one, but to be honest, I don't know how Mark is doing that. So you need to send an email to him for the others.
If you have access to terminal, I think it would be just.
No, I did for one, but we have like 6 VMs, right? So that's
Yeah.
so you can access the one for this channel. Please, before connecting, check that your BNC is not changing the resolution. That's really important.
Mm-hmm.
There is an option to don't configure it to change the resolution.
Yeah, I think I got it. I'm gonna launch it
Okay.
now.
Yes. So
Yeah.
how
Okay.
prepared do you feel?
I just ended it because I didn't want people to see that. Like, yeah.
Okay.
Okay. I
Yeah,
think
but
I'm,
it's, I don't
yeah.
know if there is no one here. Right? It's only us.
Oh, okay. Well, it's live on YouTube.
Oh yeah, and YouTube, I have no idea.
Yeah.
Like, hello, YouTube people.
Right. Gosh. Okay. So that works, and I can just relaunch like this, and then I would say, "Ooh, now relaunched, right?" Yes.
Yeah.
Cool. Phew.
Yes.
Thank you so much.
You're welcome.
Okay. I'm gonna go deal with the rest of the help desk tickets now. But I will stay here because I will spend the whole day in knee. So yeah.
Okay. Cool. Yeah, I have to move to the next one to configure the ads.
Yep.
But first I want to confirm that Ian has access to.
Yeah, we'll check with Mark. I'm
No,
setting
but
up.
I added your key to this VM, so you can test this
Okay.
one. But I didn't want to do all of them manually. So.
Yeah.
But you are going to be. Where is your first room?
In Parrot.
Okay, yeah. So I can also add it to Parrot, so you have the VM for Parrot. But check that you can connect now. So you should be able to connect, and so then I'm going to Parrot. That's webinar 4. Again, remember to turn off the resolution.
Yep. I'm in.
Okay. And do you want to test it? So
I just installed the VNC so on this
okay.
machine, so I'll just turn it on.
Okay. Again, remember before, because if you change the resolution, it breaks everything. So you need to.
Yeah.
I just realized that the poll that I was looking at was requested was the next day. So yeah, sorry for wasting the time.
It's okay. It's no wasted time. Never. So which one is this one? Okay, so I'm going to log it to the Parrot one. Also Parrot. Well, I started the days with some like allergies.
Yeah. Have you taken any pills?
No, because because usually I don't have allergies. So. I think it's more
stress.
Yeah, exactly.
Yeah, I
So
know.
it's going to be gone in a few minutes.
Because you, of course, you will be relaxed in a few minutes.
Now, yeah.
Okay, it is asking me for the password.
I will send you the password.
Is the resolution setting after connection or before?
Before. So go to the options of your VNC client. I don't know why you're using.
I'm using just the VNC viewer.
And you access the VM now?
Not yet.
Okay.
Python Guild στην Bloomberg, στην οποία πλέον είμαι επικεφαλής μαζί με τον Μάτο Βοσνίσκι.
Ah, there it is. Found it.
I'm using Tiger VNC, I think is the name.
Yeah, me too. It works.
Yeah, it's Tiger VNC. And in Tiger VNC, when you start, you need to go to settings. Okay, wait. Microsoft Solog. Hello.
Do you want me to allow them to talk or?
Give me a second because I need to leave the audio in the Zoom
Yeah.
because I'm
Yeah.
Okay, I'm connected to VNC.
So Raquel, Jan, I'm going to leave this one because
Yep.
I need to do some configs in the VMs, right?
Do that. Thank you.
Jan,
Yes.
send an email to Mark or a text in sorry, I was listening to them. Send an email or a message to Mark with your public key so he can add it to the VMs.
Yeah, I will test it here and.
Okay, yeah, or test this one first. So ping me in the chat if you need me. I'm going to be doing some jumping for different channels.
Thank you.
Okay. So Raquel, I'm going to share the screen from the VM and play the ad. Okay.
Yep. Yep.
Wait a minute.
Is my audio clear, Yan?
Yeah, it's good.
Cool. And so is my keyboard sound, I bet. Oh gosh. I thought you wanted to test the ads, Yan.
Yeah, but Nico is doing something with the VM.
Ah, right, okay.
But what I could do, I can try to share the ad from.
Yeah, I mean, you could just try to play it on your
On
own
my
machine,
machine,
and
yeah.
and see whether it works.
Yeah, because I had some funny moments with VLC on a Mac. So I'm going to share the screen, right?
You have to share the sound as well, and then optimize for
At Bloomberg, the success of our business relies on people like you who can look into the future and create groundbreaking technology, research, and expert
Can you stop
insight to
it
answer
for
the
a sec?
world's most
Well,
Sorry?
I did. You could have just paused, but I mean, I don't think you have shared. I don't think you ticked optimize for video clip, right?
I did.
Well, it's very low FPS though.
Yeah, that's why I wanted to use VM, because
Yeah, right. Okay.
I tried this yesterday and I saw it that the FPS is quite low.
Yeah. Did you try maybe full screen might work?
You mean to share the whole desktop?
No, like was that the full resolution you got there or?
Oh yes.
Oh, okay.
Could it be because of that?
I don't know. If you, yeah, maybe let it try again. Let it play a little bit. I usually add the intro bit so that the resolution actually sort of grows as it progresses.
Because on a MacBook you have I have pretty high resolution, so it
Yeah.
could be because of that.
Yeah, but I think it's adaptive. So if you just let it play a little bit, you might change the resolution. The resolution might go up a little bit. So yeah, try that.
At Bloomberg, the success of our business relies on people like you who can look into the future and create groundbreaking technology, research, and expert insight to answer.
Well, it's around 14 FPS, which is not great, but not completely unusable.
Is it better now?
I'm not hearing the sound.
Yeah, I know. That's expected.
Yeah, I
Kind
mean,
of expected.
yeah, you get 532 p at 27 FPS, which is decent, I suppose.
Yeah. Yeah, that's why I wanted to use a VM, because
Yeah, I mean, it's best if you could get it to work, but otherwise, I think it's okay. But when I play this, I would always try to add the intro in, the EuroPython intro in, so that it gives some buffer time. I generally go with the intro, the intro video, the ad, and the outro video.
Oh, Jesus. I cannot use VLC on a Mac, but at least not on this one. Because it looks like that the app crashes every time I played one video.
Oh God, okay.
Είμαι η Μαριάννα. Λάτρεψα την Python από την πρώτη ματιά. Αυτό είναι που με έκανε να ασχοληθώ με την κοινότητα του Python Guild στην Bloomberg, στην οποία πλέον είμαι επικεφαλής μαζί με τον Μάτου Βοσνίσκι.
Jana, you're there?
Yes.
Okay,
Yes.
so this one is ready to use. So if you see what it did is, oh wait, this is wrong. Close. So what you do is like, you need to put, the problem is that you don't have all the files here. Okay, this is weird.
I can probably download them there.
Yeah, let me check file manager, download. Yeah, you need to upload the others.
Yeah, I'm on a different room anyway, so.
Oh, you are not
But,
in.
I
You are
may-
not in what? In which one you are?
I'm in Parrot.
Okay, let me add your public key to Parrot then. Okay, I have to configure Parrot now. So if you want, you can go there and we can.
Okay. Okay, I will switch to Parrot. So let me know when I can connect.
Yeah, I need to configure the VM. So give me and I need to add your key, right?
Yes.
To that one. So 93 connect. Copy. So system terminal.
Okay.
Okay, I added your key. So you should be able to join the VNC. And now I have to make this thing showing the webinar. So here, join, password, this one, join, sponsor.
Password is same.
Yeah, it's always the same. It changed the port, right? So
Yep.
so for Parrot, now I have sponsor ads, promote to Paradise. Co-host, yes. Then go back. So this one is Parrot, and then let's do some check. Share screen. And I need to join Parrot, right? So EuroPython, Parrot track. So
Hello, Jill.
Hello.
Hi.
Is this ready yet, or
Not
just...
what? No, not yet. You're not the co-host yet, and I don't want to log into the VM, so I'll ask Nicholas to do that. Jill, you're a co-host now.
Yeah.
Okay.
I've been a host for a while, right? I think when I joined.
No, you're a panelist. You were not a host.
Oh, okay. Yeah. Let me check then. Yes, I got some cool controls now.
Yep. Okay. Oh gosh.
I'll try to configure the environment so that I can see what's happening. We already have 2 people.
Yes.
So hello, Carol. Hello, Chef Chick.
They are not allowed to talk because.
Yeah, I know. I'm just.
All right. Yeah.
Just saying the good morning.
It's nice to say hi. Yes.
Yeah. Let me see if this looks okay. My camera looks fine. I thought about tidying this up, but give me at least. Okay. So do you feel, are you ready?
No. Yeah.
I'm muting all other tracks on Discord.
Are you on?
Yeah, I need to get into so not green room. I need to be on the
You need to
breakout.
be on
Talkback.
talkback channel.
Talkback. Okay, cool.
Okay.
Is there anything that I can do to help in the meantime?
No, I think I'm just going to start preparing now. So our session will start at 9 our time, right?
Yeah.
Okay, so at 8:45, I'll be calling the first one. So the first two will be co-speakers.
There'll be two speakers, yes.
Yeah.
And we met them already, so that'll be easy.
I'll actually be just calling them now.
Cool. I don't think I met the second speaker. I don't know if I'm going to pronounce their name correctly or not.
Anyway, you'll be fine. So
they can always correct me.
Okay, so I'm gonna be muted here now.
So yeah, I'll mute myself just Ni. Ni. Hello. I will be your host for this track. Oh, right. I see the speakers already in. I hope you had a good breakfast this morning. And yeah. Oh. Someone is talking. So yeah, I hope you had a good breakfast. Did you have your beverage ready?
Yeah.
Oh, hello.
Hello.
There's a bit of an echo,
Echo.
but I'm sure
Sorry
you'll
about
be
that.
fine. Will you be both presenting from the same? Yeah, of course. Same screen. Yeah, Kunyu, I think you can turn off the volume from your Zoom. Maybe that's what's doing the echo.
Oh, test.
There's still echo. You still have 2 minutes, so it's fine. just. Do you have headphones?
Hi, could you hear me?
Oh yeah, that's good. It's perfect now. Can I just do one?
你声音从这里 output 出来。对，你要用哪个？直接这个。Hello. Is there any echo?
Yeah, I could hear myself on the walkie-talkie. So if you wear a headphone, and if just one of you wears like a little headset, just so I can tell you how long it will take, or like how long you have, and then there's no sound coming from outside. Yeah.
你开吗？
Can you try speaking a bit, just because I think it's good now. Sure. Can you hear me? Can you try saying something?
Is everything okay?
Yeah, I can hear you. So how about we just go with this? I will talk through here about like the time you need, or maybe you know what, I could like just write something for you. I'll be giving you the spotlight, so nobody will see me. So right. So welcome to Ni. Junwei and Kunyu Chan will be talking about antivirus. Give them a big hand.
Sorry for that. I know we're starting. Okay, let's get started. Okay. Sorry for that. Okay, so hey guys, welcome to join our live sharing talk. Today, our topic is, so you want to build an antivirus engine, and we'll be demonstrating our engine, Quark. It is an obfuscation neglect Android malware scoring system. So, my name is Kunyu Chen. I am a security researcher and a founder of Quark Engine. And we also have another speaker, Junwei. He's the co-founder of Quark Engine, and he gave talks in security conferences like HITV and DEF CON. So this is the outline. Number one, we will introduce our malware scoring system. And number two, we will show you how we designed the Delvik bytecode loader. And number three, we will go through two cases of real malware analysis using Quark Engine. And the last thing, yes, the future works. We still have a lot of things to do. All right, so let's introduce the malware scoring system. As we know, when developing a malware analysis engine, it is important to have a scoring system. However, those systems are either business secret or too complicated. Therefore, we decided to create a simple but solid one and take that as a challenge. And since we wanted to design a novel scoring system, we stopped reading and decoding what other people do in the field of cybersecurity, because we don't want our ideas to be subjected to the existing systems. So we started to find ideas in fields other than cybersecurity. And luckily, we found one. Yes, the best practice we found is the criminal law. So, when sentenced a penalty for a criminal, the judge weighs the penalties based on the criminal law. And after decoding the law, we find principles behind it. And we developed a scoring system for Android malware. There are only 8 principles decoded from the criminal law, and I'll go through it in the following slide. Now, let's see principle number 1. A malware crime consists of action and targets. In the criminal law, the definition of a crime consists of action and targets. For example, steal money and kill people. So with this principle in mind, we developed the definition of a crime for Android malware. And the definition is the malware crime consists of action and targets. For example, steal photos or steal your banking account passwords. Now, let's see principle number 2. We consider that the loss of fame is greater than the loss of wealth. In the criminal law, physical body injury is more serious than psychological injury. So the principle we decoded here is when things are hard to recover, we consider it a felony. With this principle decoded, we developed our second principle. We consider the loss of fame is greater than the loss of wealth, because it's easier to make your money back than rebuild your reputation. Okay, now let's see principle number 3, arithmetic sequence. In the criminal law, when the murderer is sentenced 20 years in prison and a robber is sentenced 7 years in prison for his crime, have you ever think about why 20 and 7 years? Why the number? And we found no obvious principle in the criminal law. So we use arithmetic sequence to weight the penalty of each crime. For example, the penalty weight of Y1, which is still banking account password, is 10. And Y2, steal photos from your cell phone, is 20. And the penalty weight for Y3 is 30, etc. So now let's see the most important part of the scoring system. We created an order theory, which consists of 3 principles. There are principle number 4, number 5, and number 6. So let's first look at principle number 4. The later the stage, the more we're sure that the crime is practiced. And as I mentioned, as mentioned in chapter 4 of Taiwan criminal law, each crime consists of a sequence of behaviors. And those behaviors can be categorized in a specific order. So let's take murder, for example. In stage 1, determined, it means somebody decide to kill someone. And in stage 2, conspiracy, it means that he or she started to make a plan for the murder. And in stage 3, preparation, it means buying stuffs, for example, weapons, or arranging services for the murder plan. And in stage 4, start, it means when things are all set, the murderer takes action and is on the way to kill someone. Practice, the last stage, stage 5. It means the murderer does pull the trigger and shoot someone. So as we can see here, the later the stage, the more we are sure that the crime is practiced. So, with this principle in mind, we developed Android malware crime order theory. And in this theory, we also have 5 stages for a crime. For example, if a malware tries to send out your location data by using SMS, in stage 1, we will check if related permission is requested by the malware. And then we will check if the key native API is called. And in stage 3, we will see if certain combination of native API exist. And then we will check if the APIs are called in a specific order. Finally, we check if the APIs are handling the same register. Okay, so now you can see from this picture, this is a 2-dimensional map for Android malware crime. And for the crimes, we put them in y-axis. And for each crime, we use x-axis to see if the evidence, we caught for this crime. So x5, y1 means in crime number 1, we have found native APIs that are called in the correct sequence and they're handling the same register. And x3, y5, it means in crime number 5, we have found certain combination of native APIs that are used in this APK. So now, let's look at principle number 5. The more evidence we caught, the more penalty weight we give. So we give stage 2 more weights than stage 1, and we give stage 3 more weights than stage 2, etc. Okay, principle number 6, proportional sequence. As we decode it from the criminal law, the later the stage, the more we're sure that the crime is practiced. So we consider proportional sequence, for example, 2 to the power of n, to present such principle in our scoring system. All right, principle number 7. Crimes are independent events. So for simplicity, we assume crimes are independent events, and penalty weight can be added up directly. So this is an example of adding up 2 crimes. In the malware, we find 2 crimes. There are stealing photos and stealing your banking account password. So the calculation of the total penalty weight actually is quite simple. For each crime, we use penalty weight of crime to multiply the proportion of caught evidence and add up the results of the 2. The last principle, principle number 8, threshold generate system. So after calculating the total penalty weight for the malware, we need to have threat level threshold so that we can tell which threat level does the malware fit in. Unfortunately, we can't find them in the criminal law, but we know we need to design a threshold generate system for that, not just give any number by intuition. So we decided that threshold for each threat level is the sum of the same proportion of caught evidence multiplies the penalty weight of crimes. Yeah, we know this is not a perfect one, but we're sure that we build a foundation for future optimization. All right, now let's talk about the design logic of Delphic bytecode loader. And my partner, Junwei, he will take care of this part.
Hello everyone, my name is Junwei, and I will take care of this part. So now, let's talk about the design logic of Delphi bytecode loader. Our Delphi bytecode loader is actually the implementation of the Android malware crime order theory. We implement every stage of the theory. There are 5 stages. The first 3 stages are easy. We simply use APIs in another open source tool, AndroidGuard, to implement the first 3 stages. As I just mentioned, the implementation of the first 3 stages are easy, but in stage 4, we need to do a little bit more. So, before the implementation, we need to know what does stage 4 do. In stage 4, we find the calling sequence of native APIs and check if they are called in a specific order. For example, if a malware sends out your location data by SNS, then first it will call native API get cell location to get your location data. And then it will call native API send text message to send your location data by SNS. Normally, native APIs are wrapped in functions. So we trace back to see which function is cross-referenced from the native APIs. And we call those functions the parent function. And we will keep tracing back until we find the mutual parent function for both the native APIs. Here is the example. Send text message is called by send SNS, which is the parent function of send text message. And get cell location is called by get location, which is the parent function of get cell location. And if we keep tracing back, we will see that both send SNS and get location shares the same parent function, which is send message. And after we find the mutual parent function, we will scan through a smally like code of the mutual parent function and check which function is called first. So this is the smally like code of send message. We can see that get location is called first to get location data of the cell phone. And the send SNS is called to send out the location data. In stage 4, we found out that our design can also overcome the obfuscation techniques used by the malware. When applying obfuscation techniques, functions except native APIs are renamed. This has made the decompiled source code hard to read for human. The machines can still run the code because the logic of the code remains the same. Here is the example. When applying obfuscation techniques, native API send text message is called by function K, and function K is called by function F. The alternative API get cell location is called by function E. And both function E and F shares the same parent function, which is A. So you see, if you start reading the decompiled source code of A, it will be hard to figure out what is going on there. And by the way, since our goal is to find a mutual parent function, so it doesn't matter how many layers the wrappers are. Now, let's see the implementation of stage 5. Yes, this is the most important part. In stage 5, we need to confirm that if the native APIs are handling the send register. Let's use the send example. Send out your location data by using SNS. So, when native API get cell location is called, it will return the location data of the cell phone. And what we do in stage 5 is to check if the other native API send text message sends out the location data returned from get cell location. So in stage 5, we simulate the CPU operation. We will read line by line of the Smalley-like source code and operate like CPUs to get two things. First, the value of every register. 2, the information like functions who have operated the send register. To make this happen, we create a self-defined data type, and we call it register object. In each register object, we store 3 kinds of information. Number 1, the register name, and number 2, the value of the register, and number 3, the function who use this register. Let's see the example. So the register name is V7, and the value of the register is a string. And the string appends the value of string 1 and the result of function 1. And then we can see that the register is used as the input source of the function 2. And by the way, when filling in the value of use by which function in a register object, we expand every register by cross-referencing other register object in a table. So, for example, by cross-referencing, we know that V8 is a string called user location, and V3 is a function called get location. As you can see in the lower right corner, the result of get location is appended to the string, which is user location. And the new string is sent out by using function send SNS. In other words, the value of register V7 is generated by using function get location, which has native API 1 in it. And the value is used as an input for a function send SNS, which has native API 2 in it. So now we prove that by using the register objects, we can check if the APIs are handling the same register. So after we scan through the source code, we will produce lots of register objects. And those register objects will be organized with a two-dimensional Python list. It is a similar idea like hash table. We use it to boost up the read and write of the list. So now, let's see the table. As you can see here, register v4 has 3 register objects. That means in the source code we scan, v4 was used 3 times. And every time when it was used, we store the present value of the register. And the function who use it if there is one. So basically, the whole table is the history of the registers. So when we finish constructing the table, we then scan through all registered objects in the table to check if the native APIs are handling the same register. So now, let's see how to use Quark engine to analyze the malware. Now, let's get back to Kunyu.
Hi, it's me again. So, in this section, we prepared 2 malware. One is non-obfuscated, and the other one is obfuscated. And for each malware, we will show how we detect the behavior of the malware with the detection rule. Now, let's see the first malware. This is a non-obfuscated one. We will use the rule in Quark engine to detect whether if the malware sent out the cell phone's location data by using SMS. So, this is the detailed report of Quark engine. And in this report, the engine shows the detection result of one single malware behavior. Or you can say, one single malware crime. So, for example, we try to find if the malware sent out your location data by using SMS. In this report, we list out the evidence we found in each stage of the Android malware crime author theory. And this report shows we find evidence in every stage, which means we have 100% sure, we have 100% of confidence that the malware has this behavior. So let's see. In stage 1, permissions like send SMS, access course location, and find location are requested. In the second stage, key native APIs like get cell location and send text message are used. And in stage 3, we found certain combination of native APIs exist. And in stage 4, we found out that in functions like send message and do byte, the APIs are called in the right sequence. And in stage 5, in function send message, we found out that those APIs are handling the same register. So now let's think. If you're analyzing this malware and you want to trace the compiled source code to see the evidence, how do you do it? Our suggestion is, if you are reading the detailed report generated by Quark Engine, we suggest that you read the report backwards. That means you start reading from stage 5. For example, in stage 5, we know that inside the function of send message, it has 2 functions that contains the 2 native APIs respectively, and they're handling the same register. So you start to locate function send message in the decompiled source code. And in stage 4, we know that those 2 functions are called in the right sequence. So we can start to find functions that contains the native APIs and check if they are really called in the right sequence. The information of the 2 functions and the sequence will be shown in the next version of Quark Engine. So now let's look at the real malware example. So as you can remember in the previous slide, we need to locate the function send message in the source code. And we found out that 2 functions that contains the 2 native APIs respectively. There are send SMS and get location. And if we dive into the source code of function get location, we will see that it contains native API get location. And if we dive into the source code of function send SMS, we will see that it contains native API send text message. So the decompiled source code here, it means this malware will first collect your cell phone location data and send it out through SMS. So now let's dive into the source code of get location. As you can see in the source code, it tries to call native API get cell location and return this information at the end of the code. And now let's dive in the source code of send SMS. Native API send text message is used to send out the location information. So that's how we've used the Quark Engine to find the evidence in a malware. Quite simple, isn't it? Now, let's look at the second malware. This is an obfuscated one. We will use the rule in Quark Engine to find whether if the malware detects Wi-Fi hotspot by gathering information like active network info and cell phone location. Okay, so as a malware analyst, we read the report backwards. So as you can see in stage 5, there are functions like p.a, @view.c, and af.run. And those functions, they have two functions that contains the native APIs respectively. And they're handling the same register. And in stage 4, those two functions are also called in the right sequence in function p.a, @view.c, and af.run. So, according to the report, we can say that the malware has the behavior of Wi-Fi hotspot detection in 3 parts of the source code. We can pick any part for further analysis. So we pick function p.a. So now let's see the source code. Let's locate the function p.a. And we found out that 2 functions that contains the 2 native APIs respectively. They are ap.a and f.f. And if we dive into the source code of function ap.a, we will see that it contains native API, get active network info. And if we dive into the function f.f, we will see that it contains the native API, get cell location. So the code here means after collecting information from function ap.a and f.f, they send the information as an input for function am.a. So now let's dive into the source code of function ap.a. So as you can see in the source code, it tries to call native API, get active network info, and return the related information at some point. Now let's dive into the source code of f.f. Native API get cell location is used to get the cell phone location data. And this information is processed with some other strings. And at the end of this function, it returns a string with the information. As I mentioned earlier, after collecting information from function ap.a and f.f, they use the information as an input for function am.a. And we notice one thing. The function am.a uses byte array output string as one of its input parameter. And we know when seeing byte array output string, it means the function is probably trying to write the data into a file. So we show again how we use Quark Engine to find evidence of malware activity in the binary. So this is amazing, isn't it? So with Quark Engine, malware analysis can really boost up their productivity. All right, the last part, future works. As I mentioned earlier, we still have a lot of things to do. For example, we need to have more detection rules, and we need to deal with the .so file and the packed APKs, and we want to have more features of the Delphic bytecode loader, for example, the feature of downloader, and we also want to apply our scoring system to other binary formats. And the last thing, we probably would change the core library since we use AndroGod, and since AndroGod is quite inactive recently. Okay, that's all for today. And if you have any question, please feel free to ask. Thank you.
Thank you, Jermaine. Thank you, Kunyu. There's no questions so far. I did forget to tell people, do you use the Zoom Q&A function? In the meantime, I can ask you one thing. So, I hear a bit of echo, but it's fine. I'll endure. What made you interested in doing this work with the antivirus?
Sorry, can you say that again? Because the speaker is quite.
Oh yeah, no worries. What made you interested in this subject?
What is the most interesting part?
For you, yes.
Okay. The construction of finding, the process of constructing the malware scoring system. And also, we have experienced the unexpected part. For example, the function of this engine, we can find the, we can neglect the obfuscation part. That is unexpected part. So we went through an adventure and we did meet something that is unexpected. That's the most interesting part.
Nice. Takuya, I see you have your hand raised. I would ask you to use the Q&A function. Oh, okay. We have a question. So are you planning to keep this to Android only, or do you plan to look at other platforms?
Can you say that again? Sorry.
Yeah. Are you planning to keep this on Android only, or do you plan to look at any other platforms?
Yeah, we would try to apply it to other platforms, for example, the binary formats of ELF or PE files, because we found our older theory can apply to other binary formats. We would do that in the future works.
Cool, thank you. All right, so there's no more questions. Thank you again for the talk. And we will be doing a break now.
Okay.
Thanks so much. So, and I bet people at home are clapping as well. So, yeah.
Yeah, sure, no problem.
Cool. Okay, so I see you there already, Takuya. Hello. So where are you zooming from? Oh, I guess you can't hear me, but yeah, okay, we're on a break anyway, so.
Okay.
By the way, since the next track isn't now, feel free to just turn your camera off and your sound off, unless you want to take the break just looking at the computer. That's fine as well.
Okay.
Okay, so we're back from the break. I hope you had good food. I heard that the crisp sandwiches are amazing, and the coffee is especially incredible, almost like the one I have at home. Surprising efficiency. Okay, lots of people now. Let me. Where's Takuya? Hello.
Hello.
Oh, you're there. So how are you today?
Oh, I'm fine. Thank you.
Where are you zooming from?
I'm participating from Japan, and this is my first time English presentation, so I'm a bit nervous now.
Oh, don't worry. This is like, yeah, it's not
Thank you.
everyone's first language. It's not my first language either. So yeah, you'll be fine. Especially since you can't see people, so you can just assume that people are loving your talk and they're like clapping, taking pictures. Maybe not taking pictures, but all right. Okay, so let's start now. So Takuya Futatsugi, is that right? Takuya Futatsugi.
Yes.
Will be talking to us, bringing your Python scripts to more users. Give him big hands.
Thank you. So let's get the ball rolling. This is a quick tour from CLI through GUI to web app with image reduction script. Let's go on a tour. Nice to meet you. Please call me Nikki. Nikki is my nickname in Japan Python community. I'm participating from Japan. Thank you for the opportunity to speak online. I use the ID ftnext on Twitter and GitHub. I'm working on natural language processing at Userbase in Tokyo. I'm an enthusiast to automate boring stuff with Python. I've been staff of PyCon.jp since last year. I'm wearing PyCon.jp shirts today. PyCon.jp 2020 will be held as an online conference on August 28th and 29th. Tickets for attending a conference session are on sale. I hope to see you at PyCon.jp again. So, why am I telling you bringing your Python script to more users? After reading a first Python book, you can write a Python script to automate the boring stuff. It's beneficial to have Python do the boring stuff for me. Your Python script should help others for have similar boring stuff. In this talk, I'll share how to bring your useful script to others. I'm glad if you try one of what I introduced after your first Python book. This talk is a quick tour. I will share 3 implementations to convert your Python script for others to use. 3 implementations are CLI app, GUI app, and web app. What kind of boring stuff am I talking about in this talk? This talk deals with resizing images to a small size as an example of boring stuff. I have a lot of images of varying sizes. This is last year PyCon.jp pictures. I want to resize all images to fit in 300 pixels square, keeping the ratio. For example, the image on the left is longer in width than in height. So resize this image to a width of 300 pixels, keeping the ratio. Resizing them small by hand, one by one, is tedious, so automate it with Python. I wrote a script, shrink image py, referring a first Python book. To operate images from Python, I use pillow package. I put all the images in one directory. Use pathlib to find the path of the images in the directory one by one. In resize image function, open the image with path, calculate new size to keep the ratio, then resize the image and save it. This function returns true if and only if it resizes the image. I put all the images in img pyconjp directory. Script shrink image py resizes images in this directory. After execution, I get a directory called images of smaller sizes. We are ready for the main talk. Our first stop is this quick tour is CLI, command line interface. There is an issue with the current script. It is hard coding. The target directory is hard coded in the script like this. So we need to edit the script to target a different directory. To resolve the issue, we modify the script to specify the target directory from the command line. Specify from the command line, so this is CLI, like this Python script, args. There is no need to edit the script every time you run it. There are several ways to do it, but I'd like to introduce argpath from the Python standard library. Let's look at an example code that introduces argpath. In the first line, import argument parser from argpath, then create a parser, add argument to the parser, and pass arguments. That's all you need. The 4 lines allow the script to take arguments from the command line. The name attribute of the variable args is the value we specified in the command line. In the above example, now we need to specify some value from the command line as name. This case is name is not specified, so help message is displayed. In the below example, if you pass EuroPython as a name argument, the script prints a message, hello EuroPython. It's time to modify shrink image py. Import argument parser, create a parser and add argument, then pass args. The hard code of the target directory has been removed now. The target directory is now specified from the command line. We don't need to change anything else. It's easy. In running the script, you can pass the directory where the image is located from the command line, like this part. The script resizes images in that directory. We do not need to edit the script every time running it. Next, we will brush up on this CLI app. We brush up the script to specify the maximum length from the command line. The maximum length was set or hard-coded as 300 pixels. We will be able to specify this. Are you getting used to seeing argpath code? The point is the double hyphen in add argument. Here, double hyphen. Arguments that start double hyphen are optional to specify. Arguments without double hyphen are required, and the specified order is important. This example shows 2 parameters of the add argument. If you do not specify the type parameter, passed values are string. Due to specify type equal int, entered value is converted as an integer. The default parameter specifies the default value. If you do not specify max length from the command line, it will be 300 pixels. Let's run the updated CLI app. In this time, we specified double hyphen max length 200. images have been resized to smaller sizes than before. Here is a tip to make the CLI app easier to use. You'll be surprised when you see the traceback when you type an incorrect path. There is typo. The path does not point any directory, so the script raises file not found error. To prevent showing this, specifying a function to type parameter of the add argument method. Here, a function existing path converts string into path-free path. After creating a path object from string value, check if the path points to an existing file or directory. If not, it raises exception, argument type error. We updated the script to prevent the user from seeing the traceback. I introduce argpath to you. Argpath allows you to specify arguments from the command line. There is no need to edit the script. Add argument method required arguments with heading double hyphen and optional arguments with heading double hyphen. Using type parameter in add argument, convert string values specified in the command line to other types. To learn CLI more, please visit the appendix. Our second stop in this quick tour is GUI, Graphical User Interface. You can now create a CLI app. Everything has strengths and weaknesses. Developers are familiar with CLI apps, but non-developers might not be familiar with them. I want non-developers to use this app. Let's think about how to make the app more user-friendly than CLI. Now it's GUI's turn. There are many GUI apps on PCs. GUI apps should be more familiar and user-friendly to non-developers than CLI. In this part, we will convert the CLI app to a GUI app like the right image. User can specify a path of the target directory and max length on the screen. I'll show you a demo. This is a converted GUI app, and enter the target directory, max length to smaller, quick resize, displays resize images. There are several packages to build GUI apps, but I'd like to introduce Eel. Eel could make it easier to implement GUI apps. Note that to use the Eel package, Google Chrome needs to be installed on your PC. A GUI app made with Eel has 4 components. One, of course, is the Python code. I will explain HTML and JavaScript. They are essential for the Eel app. CSS is optional, so if you want to know, visit the appendix slide. HTML is code written using tags like upper right. It defines the structures of GUI apps. Google Chrome shows the input field comes first, then the button next. If you want to learn more, visit this link. JavaScript adds interaction to GUI apps. For example, when a user clicks the button, JavaScript changes the screen by rewriting certain tags in the HTML. The critical difference with Python code is that JavaScript requires trailing semicolon, and before variable, JavaScript requires let or bar. I am devout Pythonista, so semicolons and let is easy to forget to me, but JavaScript doesn't work well without them. This is a key point. Eel allows you to call functions written in Python from JavaScript. This allows you to convert a Python script into a GUI app with just a little HTML and JavaScript. If you want to run more JavaScript, visit this link. The three components are arranged in two files, a Python script and an HTML file. In Eil's way, an HTML file is often placed in a folder called web. JavaScript is written in this HTML file because we write a little. Let's build a simple GUI app. When you click the button, this app displays hello world and random number. I will share two things: how to execute a process by clicking the button and how to change the screen. The directory structure is the same as before. One Python file and one HTML file with JavaScript. A Python function, say hello, returns string greeting message with a random number, such as hello world 1. The point is a decorator, EuroExpose. JavaScript can call functions decorated with EuroExpose. EuroInit and EuroStart allow to use hello HTML under the hello directory. HTML consists of two parts, head and body. In the head tag, you write JavaScript. In the body tag, you write other tags to define a structure. I've defined greet button and an empty paragraph. The paragraph has an ID, greeting. JavaScript uses this ID. There is a button on the top of the screen, and below it, there is an empty paragraph. The point is the attribute onClick. This code means when the button is clicked, JavaScript function greeting is called. Function greeting is called when a user clicks the greet button. It's a unique writing style, a series of parentheses. JavaScript first calls sayHello function in Python file and waits for the return value. After receiving the return value, hello world random number, JavaScript calls print greeting function written in JavaScript with the return value of sayHello function. This writing style of waiting for a return value is called a callback. The print greeting function operates on an HTML tag ID greeting. So print greeting can rewrite the console of the paragraph. Rewrite this paragraph. When you call this function with the message hello world 1, the contents of the paragraph changes to hello world 1. So users see a greeting after clicking the button. That's it. Now it's time to convert the image resize app to GUI app. I'll share how to handle input values. You're getting used to arranging the two files, Python files and an HTML file. We'll put the resized images in the images directory under the web directory. The Python code is the same as before. Create a function resize and decorate with EuroExpose. Now we can call it from JavaScript. You can manipulate files on your PC from Python without restriction, but from JavaScript, there is some restriction. So pass the directory path as the user enters it, and let Python operate it. Resize function returns a list of file paths for each resized image. In JavaScript, we use this list to rewrite contents in HTML. The HTML defines fields that the user can enter. Users can specify the target path and max length on the screen. Set the onClick attribute of the resize button to call the JavaScript resize function. When the resize function of JavaScript is called, it gets the target path and maximum length using the tags IDs. Here code. Then JavaScript calls the Python resize function, resize, with the entered values. Using callback, after waiting for a list returned from Python resize function, JavaScript calls list up images function. The list up images function rewrites the HTML using a list of image paths. To display an image in HTML, use the img tag and src attribute of the image img tag, specify the path to the image. This needs to be a relative path to resize HTML, and Python function already returns the relative path. List up images function writes some img elements into the empty div element. Users can see the resized images on the screen. You can distribute EUR app, install PyInstaller, then type this command to create distributable binary. Distributable binary at dist directory. In my case, using Mac OS, so distributable binary is for Mac OS. Note that distribution requires knowledge of PyInstaller. In some cases, distribution may not be easy. I introduced EUR to you. EUR has 4 components: Python, HTML, JavaScript, and CSS. EUR enables JavaScript to call Python functions. To execute a process by clicking a button in HTML, set a JavaScript function. To handle input and display on the screen in JavaScript, get the entered values and rewrite the contents. To learn GUI more, please visit the appendix. Our final stop on this tour is web apps, web applications. I'll tell you again that everything has strengths and weaknesses. GUI apps are user-friendly to non-developers, but distribution is sometimes tough because of OS dependency or some pitfalls. GUI apps need to be installed, so some users may feel installation is a bit difficult. Can we avoid distribution and installation? Now it's web app's turn. Once users connect to the internet, the app is immediately available without installation. Web apps have GUI and it is easy to start using. The web is a mechanism for sharing information and one of the ways we use the internet. Try the app from the link. The link, if you open the link, see this page and select images. Show display besides image. In CLI and GUI parts, we were thinking about a single machine. In web app parts, we are thinking of more than one machine. Multiple machines can be classified into 2 roles. The server is a machine. There is web app is running. We put the source code on servers. The client is a machine that uses web apps. For example, we use web apps from browsers in our PCs and smartphones. This slide shows the communication between the server and client. The client sends a request to the server. The server runs the process based on the request. Once the process is completed, the server returns a response to the client. What's in the request and response? A request includes a URL, a string starting with HTTP or HTTPS. URL shows which server to access and which process on the server to call. A request also includes information entered into your browser. The server processes this. A response includes HTML as a string. Here is the good news. We can recycle HTML files in the GUI part. There are several packages to build web apps, but I'd like to introduce Flask. Flask could make it easier to implement simple web apps. A web app has 4 components. I wish I could tell you all of them, but this talk will only deal with Python and HTML. JavaScript and CSS are optional, so not covered in this talk. In Eve, JavaScript handles interactions, but in a web app, Python code in the server handles instructions. We'll start with a simple example to be familiar with Flask. When you open the URL in your browser, the app displays a greeting, hello world, and random number. The directory structure is similar to real apps. Create two files, a Python file and an HTML file. By running the Python script, you can start the server on your PC. You can send a request by it. You can send a request to server by opening this link. When the user opens the URL in the browser, it sends request. The server once receives the request, it starts the process corresponding to /hello. After completing the process, the server returns a response. The browser receives the response and renders HTML on the screen so the user can see a greeting. In Python implementation, first, create an instance of Flask. The point is to decorate hello function with app root. This hello function processes all requests to /hello. The function gets a string greeting by calling say hello function. It returns a response by render template function, which creates a response based on templates hello HTML and variable message. Next, HTML implementation. Flask's render template function can handle not only HTML, but also Jinja2 template tags. This tag is Jinja2 template tag, and this is replaced by the value of the variable message in HTML. So in returned HTML, we do not see a double curly bracket. Create image resize web app. When you open the app's URL from the browser, you see a screen like the left image. Specify images and lengths, then click the send button. Then the web app resizes the images and displays them like the right image. So, it takes a long for processing, but succeeds to resize. If a user doesn't specify an image, the screen displays in the same way as it does in the hello world example. So /resize request and process, so return response. How to handle images in web apps? After the user specifies an image, the client sends a copy of the data of the image to a server. The web app loads the image from data, resize it, and save on the server. We need to save the image at public directory on the server. img tag works for public images on the server. Put the resized image in the images directory. This directory will be published. In Python code, the difference between hello world py and this is a static folder argument here. Images in the directory can be displayed in HTML. Resize function is decorated by app root. So the resize function processes requests include /resize URL. When you open /resize in a browser without sending any image data, you will see the following slide HTML. Here is code in the body tag. It defines input fields. When an image and maximum length are specified and the send button is clicked, the data is sent to /resize. In this time, the condition of the if statement becomes false. So code in this slide is executed. Python receives the max length and image file in the request sent by the browser. After resizing the image data, save it to the image directory on the server. Render template function receives a list of paths of resized images. When the list is passed to render template function, it creates a response based on these template tags. As with the for statement in Python, this template tag create img tag for each image. Here's how to build the demo app I mentioned earlier. Several services allow you to run your code as a web app. To run your app on Heroku, install gUnicorn, create config files for Heroku, and then push your code to Heroku. Recap time. Web app receives a request from a client and returns a response. I introduce Flask to you. Flask executes a Python function corresponding to the URL in the request. Flask creates a response using template tags. In web apps, to display the images in HTML, you need to set images to publish on the server. In Flask, use static folder argument. To run web app more, please visit the appendix. Here's a recap of this tour. In CLI, we reserve the hard-coded by specifying from the command line. GUI app is more user-friendly and easier for non-developer to use. To build a GUI app, we write HTML and JavaScript are written. We can use web apps as soon as you connected to the internet. No installation. In web, we need to sync communication with a server and a client. In a server, Python processes send data. So that's it. Bring your script and automate someone's boring stuff with your Python script. Thank you very much for your attention.
Thank you, Takuya. Awesome. There's no questions, but there's no time, so
okay.
We'll just move on to Leonardo's.
Okay,
hello,
thank you very
Leonardo.
much.
Hi all.
How are you?
I'm good, thank you. Thank you for being here. Well, it's good to see you on the other side of the screen, you know, because it's a bit scary here. Looks like there is no one there.
I'll try to be the audience.
Thank you.
All right, so are you ready to start?
Yes, let me share my screen. Can I share the whole screen?
Yeah, you should. So if anyone has a question, do use the Zoom's option for the Q&A, and I will make sure to ask your questions in the end if we have time. So give a big hand to Leonardo.
Thank you. You can see my screen right now. Yeah.
Yes, yes.
Okay, great. So thank you. Welcome, everybody. Today, I will talk about the clean architecture in Python. The subtitle of the presentation is a tale of durability, utility, and beauty. And I hope it will be clear during the talk why I gave this subtitle. First of all, who am I? My name is Leonardo. I am a software developer and a blogger. I work in the cinema industry recently. I am into infrastructure, working with AWS, Terraform, and all these fancy things. As I said, I'm also a blogger. I have a blog which is called The Digital Cat, and you can find it at the address there. I blog mostly about Python, but many other things. So yeah, come and pay a visit. I'm a cat person, and I like to say it because there is one specific thing I like about cats. They are very curious. And I like curiosity. I like to be, into things, to dig into things and to understand how they work. So let's get into architectures. So what is architecture? This is the first question I have and I want to answer. We can go around here in the picture. I have the Cathedral of Florence. We can go around and say, oh, this is a beautiful building, right? This impressive.
Sorry, Leonardo. We don't see the cathedral. Maybe that's your background. It's Space Invaders.
Oh,
class.
sorry.
Sorry, I thought that was your slide.
Let me share it again. Can you see it now?
Yes, we can.
Great. Sorry for for this. So this is my blog. Okay, if you can see the cathedral now, you know, you can pass by and say, oh, this is an impressive architecture, right? This is an impressive building. It's very beautiful. But what do we mean when we say architecture? And so I dug into this and I found out that Vitruvius, who was a Roman architect, he was born around 70 BC, so more than 2000 years ago. He wrote a book which is called De Architectura, which means on architecture. And he says that every building should have three attributes, which are firmitas, utilitas, and venustas. They can be translated in English into durability, utility, and beauty, hence the subtitle of the talk. So what Vitruvius says is that whatever we build should be durable, useful, and beautiful. And there is another translation for durable, which is strong, but I prefer durable because it gives the idea of something that lasts, you know, that stands the test of time. And I want to spend 1 second about this. Think about your software. Think about what you create. How many times it is durable, useful, and beautiful. Usually it's useful, I hope. Durable, you know, like how much time does pass until your software becomes obsolete, for example. And beautiful, not to mention, sometimes you look into your code and it's ugly. So I went a bit more into the definition of architecture. And the dictionary gives me these are the definitions. This is specifically for software architectures. And the dictionary says the art and science in which the components of a computer system are organized and integrated. And I was struck here because it's art and science. So now think about it, art and science. So how many of you consider themselves artists and scientists? You know, we call them ourselves coders, usually, you know, engineers, but art and science, which means that what we do when we write that code is art, and we have to treat it as that. And there is another thing that I want to mention about this definition. It says organized and integrated. So organization is about where things are in your system. So when you create a software, where are the components? Not only where they are physically speaking, but where are they in the system, in the diagram, you know, in the chart? And integrated. So how does data flow between the components when you use the system? Okay, and now that I maybe defined architecture, let me discuss if we need it. And many people believe I chose this picture because maybe the house here is not an impressive building. But on the contrary, I chose it because I was struck by this. When I saw the picture, for something completely different, when I saw the picture, I thought, whoever built this didn't have the best, you know, the best materials, or maybe the best science, because, you know, this is a bit leaning, it's not perfect. But they wanted this building to be beautiful, to last. They have a roof, they have a door, you know. So it's poor, maybe, but it's beautiful. And this is what I want to say about, the main thing I want to say about architecture. We need architecture because we want the things we do to be beautiful. We need it. So it's good for us to study and to discuss architecture, because in the end, what we do can be beautiful, can be durable. And the other thing I want to mention, this is a bit more technical, is that if you don't decide for an architecture, if you don't commit to an architecture, if you don't think about it, well, someone else will think for you, will decide for you. And usually this is the framework that you use. So I know for sure that, you know, in the Python world, many people use Django or Flask, for example, they are impressive frameworks. I like them a lot. I'm not here to say they are not good. But think about this. When you use one of those frameworks, you are automatically committing yourself to the architecture they push. One example, in Django and in Flask as well, models are connected with the database. And usually the database is a relational database. And these are architectural choices. And you commit to them automatically because you commit to the framework. So this is what I mean. You have to think about the architecture. You have to care about it. And people have been discussing architectures since the very beginning. So I just listed here some of the books that I read in my career. They are very useful, they're very interesting. A word of caution, so these books are not, like readings for when you lie on the beach under the sun, that you have to study these books. So if you don't want to commit to these door stoppers, because they are very thick sometimes, I highly suggest that you read at least the introduction to the two books I marked in red, which are Design Patterns and Enterprise Integration Patterns. Both introductions are very fluent. They are not too technical, but they give you a great example of architectural discussion. How do you think about your requirements? How you design a system? So if you have the chance, read at least that, if you don't want to read the whole book. Okay, now I defined and discussed a bit architecture. Let's discuss the other word, clean. So cleanness. What is cleanness? I can easily show you something which is not clean. Here we go. So I strongly believe there are just a few people, or probably nobody, who wants to work in such an environment. Because I would be scared every time, you have to pull a cable. How do you know which one is the right one? In an emergency, this is hell. So this is definitely not clean. What is clean? This is clean. What is the meaning of clean? Is that in such a system, looking at this cabinet, I can say where things are. I can easily see the path of the cables. I know why the components are there. I know what something is. That there are like labels, for example. And it's easy. It should be easier to work with such a system. So the clean architecture is a way to structure your software in order to be like this, in order to be something that you can easily manipulate, it can easily work, it can easily work with. So today I have, unfortunately, not much time. I can only scratch the surface of these concepts. Lucky for you, no, I don't know if you are interested, I wrote a book two years ago, which is called Clean Architectures in Python. Is freely available at Limpub. If you want to donate, I'm not going to complain. And I discuss the example I'm going to show you today in great details, in all the details. So probably too much. So today I'm going to scratch it. If you're interested, go and fetch the book and read the whole example. The example I'm going through is that of a web service, with a single endpoint, which is /items, and the purpose of the website, the web service, is to show a list of items fetched from a data source. It's very trivial. It's really, really, really trivial. But as I said, it's architecturally interesting. It's not about the technology. So yeah. This is the clean architecture. This is the standard depiction of the clean architecture as Robert Martin drew it. Robert Martin gave these ideas the name clean architecture, but these ideas have been around since the very beginning. They are as old as computer science. And this is important because I'm not here to advertise Robert Martin. I don't agree with him on everything, for example. But this is what he calls the clean architecture. There are 4 layers called entities, use cases, gateways, and external systems. These are the standard names. And the important thing I want to mention is that the architecture is circular. So the layers are circular. What are these layers? These are virtual layers. So they are areas which your components belong to. So when you create something, a class, for example, it belongs to a certain layer. And there is an important rule in the clean architecture, which is that whatever is in a layer, like for example, here in use cases, cannot see what is outside. So for example, you create a class in Python, you know, we are talking about Python, so you create a class in use cases, you can instantiate everything that is created in the entities layer, but you can't instantiate and you can't see what is created outside. And these are just rules. That there is nothing, there is no library, no IDE, nothing in the language that enforces this. It's just the rule that you give yourself following the clean architecture. The golden rule, I'm gonna show you an example in a minute, but the golden rule is that you talk inward with simple structures and outward with interfaces. As I said, an example is coming in a second. So let's dive into the proper example. Let's start with entities. Entities are the models of my domain. So in this case, as I said, I want to list items, generic items. So as you see here, I have a class, which is called item and has 2 attributes, code and price. Not getting into the code and price now. There are just 2 attributes. One important thing, these models are very simple. If you are used to Django or Flask, you can see, I'm telling you, these models are not connected with the database. They are just containers of data. They can have methods, but they are not connected with the database, okay? So these are very, very simple models. Then we have the use cases. And let me spend some minutes about use cases. What are use cases? So they are what contain your business logic. Business logic is the most important thing in a system. What is it? Well, the business logic is the reason why you create your software or why you create your startup and, and you go and you provide some software to the world. Because the business logic is what you are able to do. Let me give you an example. Everybody can index websites, right? It's very simple. But only Google can do it that way. We can discuss if that is a good or bad way. I'm not here to advocate Google. But arguably, that is what makes Google Google, different from something else. And that is the business logic, the way they index websites and the way they are able to index websites and rank them and whatever. So that is the business logic. In this case, given it's a very simple example, we have an impressive algorithm to list items, which is, that's it. Use cases in this example are simple classes. They can be executed and basically that's it. You can just run your business logic as a sort of a recipe. We want to build a web application, as we said. So I created in Flask root items, and I connect the root with my use case. Here you can see what I mentioned about the golden rule. So the web framework has one single task, which is to receive HTTP requests and to convert them into something that the use case can digest. In this case, like for example, a dictionary. This is a simple structure because the use case can't see anything that is outside here. So it gets a simple structure. I'm passing here like request tags, it's just an example. Then you want your repository because you want to store data somewhere, right? But a word of caution. This here, I mentioned it as a database, but this should be repository because I didn't say it's a database. I didn't say it's a relational database. It's just a way to store data somewhere. It might be REST API. And we need some way to access that interface. This is another important thing. All these systems are decoupled. There is social distancing, right, in between components. If I am in the use case class and I call directly, like for example, let's say this database is Postgres, and I use psychopg. It's a library, Python library to talk with Postgres. And I embed psychopg calls into my use case. And suddenly my use case is coupled with the database. If I want to change the database, if I want to use something different, I can't. I have to change my business logic. This is bad. So my business logic should be immutable, or at least not depending on the way I store data. So I create an interface that it translates the connection with the database. So here I have the interface repo, and I pass the interface to the use case so that the use case can be aware, can use it. But as I said, it's an interface. This is a complex matter maybe, but the idea is that I'm not instantiating directly this in Python, but I'm using it as an object. So I'm just using its methods. As I said, the database interface gets simple structures like a dictionary. It translates these into the specific language, like for example, the language that Postgres uses, or you see here I'm using SQL Alchemy, because in this example, this is a SQL database. If it was MongoDB, you should use something different. Database answers with the specific language, and the database interface responds, sends back data to the use case. So the use case communicates with simple structures and gets simple structures. Entities are considered simple structures because they are, you see, everybody can see them. They are in the center of the diagram. And finally, the use case returns the data, whatever comes out of the business logic to the web framework. There is business logic here. So in this example, the business logic is almost nothing because we are just listing items, right? But for example, let's say we have an impressive algorithm to rank items according to the price. So we return the result of the business logic to the web framework. And the web framework has another task. So to be honest, web framework has two tasks. One is to translate HTTP requests, and the other one is to translate the result of the business logic into HTTP responses. Like there is an example here. Cool. So this is the trivial example about the clean architecture. And as you can see, what I did is not revolutionary. I just decoupled the systems. I have a web framework which is decoupled from the business logic. Think about Django views. Django views contain the business logic, but they are part of the framework. Instead, I decoupled them. And the database interface and the database and any other system that we can have here. Okay, one of the main advantages of the clean architecture is that it's testable. So since components are decoupled, I can take them out of the whole system and test them in isolation. This is extremely important. As for the use case, which is the business logic, is the most important thing we have to test. So we can basically look at it and think, okay, we have some input here that comes from the web framework. We can fake it. It's just a dictionary. And we can fake the database interface because, again, we are just passing some data here. And these returns entities. We can have a fake object that returns entities. We don't need the database. And again, we are returning something from the use case, and we can check that is correct. We don't need to check the HTTP response because this is not what the use case does. So this is easily testable. This is unit testing. It goes extremely fast. Then we have what are usually called integration testing. So the web framework is an external system. I need to fire it up and to have something that sends HTTP requests and checks HTTP responses. And then we have the database. Again, this is an integration test because I need the database engine running to test it. But I'm not testing the database, I'm testing the database interface. You know, like Postgres is tested by the people who wrote Postgres. I don't need to test it. Cool. So let me address a couple of questions and then I'm going to wrap up. Is it possible to migrate an existing system? It's possible. I advise you to do it bit by bit. If we are talking about a web framework, use load balancers or proxies to route some of the requests, some of the URLs into your new system. Don't replace the whole system in one go because it doesn't work. And the other thing is more important, is this the definitive architecture? And I think there is no such a thing. So it strongly depends on the requirements. So what are your requirements? The clean architecture lasts forever is a very good example, is a very good architecture, but it depends on what you are trying to achieve. So don't throw your framework out of the window after this talk. You're probably not going to do it. And yeah, think about requirements. As I said, there is a book I wrote, Go and Fetch It. There is another book written by a friend of mine, Harry Percival. He is very known in the Python community. The book is Enterprise Architectures Patterns with Python, published by O'Reilly, and it's freely available on that address because O'Reilly kindly agreed on publishing it open source. And I think that's it. I have 5 minutes for questions. I hope it was interesting enough for you.
Thank you very much, Leonardo. Yes, we do have a question from Matthew. I see the word design comes up a lot for the books you recommend. Do you differentiate between design and architecture? If so, how?
Oh, interesting. Yes, well, long story short, I think architecture is, I associate architecture more with the technical side of the thing. So how do we implement things? I didn't differentiate them that much in this talk. Design is more about where components are and what they are, what's the data flow, like technically speaking, architecture is for me more about how to implement this specific thing. But yeah, we might have another talk maybe about this. I don't know. It's a very, very long answer maybe.
Awesome. That's it. No more questions.
Okay. Thank you very much. Get in touch if we have a channel on Discord or Twitter, whatever, if you want to go on discussing these things.
Yeah, awesome. Thanks, Leonardo.
Thank you very much.
Okay, so Nicholas, are you ready? Hello.
Hi, I'm ready when you are.
Cool. Okay, where are you zooming from?
My garden shed at home.
Wow, that's nice.
It does have a wide internet connection, I hasten to add.
Oh, good. All right, and what are you going to talk to us about today, Nicholas?
This is, the title of my talk is How to Run a Corridor Track in a Remote Conference with Python. But it's about how folks use computers with each other to communicate and all sorts of fun stuff like that. Some digital archaeology as well. We're going to have some old games as well, and get inspiration from the past, as well as demonstrate a fun brain break sort of a project that I've been working on. So yes, would you like me to share my screen?
Yeah. Let's go for it. Share screen.
So can you see? Can you see that?
Yes, 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 okay. I can.
Okay, and now if I change my slides, you can see those changing.
Yeah, perfect. I also see your tabs. I don't know if you care about that.
No, I don't care at all. People can see that I'm into, I don't know, the language server protocol or something like that.
All right, so please join me giving a big clap to Nicholas. Go for it.
Thank you. So thanks for the invite. My name's Nicholas, and I'm a freelance Python developer from the UK. The focus of this talk might not be immediately apparent from the title, so let me explain a little. In this talk, what we're going to do is explore just a big subject, how humans communicate via computers, how software influences the nature of that communication. We're also going to do a little bit of digital archaeology of old technical solutions for this problem. And I'm going to sort of wrap up with a show and tell of a fun brain break experiment in recreating these solutions with modern technology. But I want to set the scene. Let me just move. I want to set the scene with this photo from EuroPython 2011 in Florence. And what it does is that it captures the wonderful nature of the corridor track. As you can see, well, I'm actually stood in the middle in the red t-shirt, and there's a collection of folks. We all appear to be holding penny whistles, which seems appropriate for a conference that could have been held in Dublin. And there's a guy with a guitar strumming away with us. It's informal, it's friendly, it's diverse, and it's fun. And this is why I love EuroPython. It's a nice place to hang out, and I get to see my friends, and I get to make new ones, most importantly. So let me just rearrange my windows so that I can see things. Yet 2020 is the year we all learned to try to stay close whilst remaining, at least in the UK, 2 meters apart. And this has been a difficult time as we learn to change and adapt to the new circumstances due to coronavirus. But I'm extremely grateful, I want to put this on public record, for the volunteers who put on EuroPython. Their efforts are often taken for granted, and you wouldn't believe the amount of stress and the number of problems they will have had to put up with. So this is especially so now that EuroPython is remote. And the current situation has also brought into focus an important question. How could folks remotely recreate the opportunity for chance encounters, unexpected conversations, and exploration of a venue and a new city with friends, which is the sort of thing that happens at EuroPython? How is such bonhomie, warmth, and friendship expressed most effectively through a digital medium, a remote digital medium? Perhaps more importantly, how do we foster tolerance and compassion, or corrections of misunderstanding and all that other good stuff needed so a diverse community full of differences and unique perspectives is able to live with itself without becoming a fractured and toxic place? So EuroPython has decided to use Discord in this sense, a chat service written for gamers. Now, I don't know about you, but I like Discord a lot. And I'm actually really pleased that EuroPython organizers chose it over other solutions, others being things like Slack or Microsoft Teams or Google Hangouts. But Discord is typical of the current state of the art in that they all look and function similarly. Yet I don't actually feel that comfortable at times with the current state of the art. So let's start by exploring my problems and discomfort with these platforms. Let's also try to imagine perhaps a more expressive, simpler, or perhaps humane alternative too. So I'm going to start by taking Discord to pieces, if you see what I mean, to see what's going on. Actually, there's a lot going on in this application. For those of us used to computers, this is often easy to miss. This is rather a complicated user interface that we can see in front of us. We are literally bombarded with data, metadata, icons, timestamps, reactions, labels, and silos are the norm for remote written interactions, such as those that we might have through Discord. And I'd also like to point out that Discord is also ultimately a very transactional sort of way to interact. And I'll come to what I mean by that in a second. But Discord isn't, this isn't the case for just Discord. This is the case for other social media sorts of platforms. So let's unpack that a little bit. So this is Twitter. There are familiar patterns in Twitter, and this isn't so much a conversation as shouting into the void through the inconvenience of a 280 character limit. And look at where all the adverts are. And here's Facebook, the redesigned Facebook. Facebook feels, to me, the most mediated platform. This is most blatantly an exercise in retaining my attention at all costs, rather than fostering a place for conversation or making friends or being friendly with people. Most problematic for me is the nature of our interactions with such platforms. Our interactions have become digital transactions. Transactions have metadata for analysis. Transactions are dislocated. There's no sense of place or occasion to such transactions. Transactions are impersonal, such as with Twitter, shouting into the void, as it were. It's hard to have a conversation. Transactions are evaluated, so we get to see likes and retweets and reactions. It's turned into a sort of popularity game. And transactions, sadly, are curated by platforms to capture our attention. Click here, react, reply, share, or only show those things that are most relevant to you. Well, who decides what that is? Sadly, our socializing is reduced to interactions that standardize, process, and normalize our lives into a digital production line of uniform social outputs. Like something, post a picture, reply with a comment, set your mood, that sort of thing. The messy, complicated, and raw aspects of life, which I would argue are the most valuable, fun, and interesting, are lost or have no way to manifest themselves through these sorts of platforms. We've commoditized ourselves into a dribble of systematized digital assets, photos, posts, likes, that sort of thing. And also, is it just me, but why do I always get the impression that the design of social media has been designed by Peppa Pig? Soft colors, cute, neutral, and just a little bit infantile in tone. Or perhaps I'm just getting old. I'm the digital version of damn kids, get off my lawn. Or perhaps current technical solutions to remote collaboration, community, and friendship feel like I'm being analyzed. My attention is being manipulated, and I either have to pay or see adverts to get anything done. None of which is conducive to me to making a place where I can have humane conversations and make friends. So, given the lockdown situation that we face, I ask myself, could there be a more natural way, creative way, simple way, expressive way, respectful way, authentic way to meet, make friends, and interact online? How do we remotely recreate the opportunity for chance encounters, unexpected conversation, and exploration of a venue and a new city with friends, but online rather than in Dublin? How could we recreate the online equivalent of our beloved corridor track, where all these friendships and lovely conversations happen? And then, as if by magic, I remembered a distant memory from my childhood. Text-based worlds with epic stories, curious locations, and imaginative adventures. And this got me thinking. So there's a bug in Firefox that means I just have to reload this iframe. So here we go. So bear with me as I go on an adventure into computer history. For the young uns, this is what a text-based adventure game looks like and feels like. This actually is Douglas Adams' own recreation of his novel, The Hitchhiker's Guide to the Galaxy, as a text-based yet interactive virtual world. So let me explain the mechanics of this. Text is displayed on the screen. The screen is up here for me. So if I'm looking away, you know I'm looking at my slides here. And I type commands in, and then reactions happen. So you wake up, the room is spinning very gently around your head, or at least it would be if you could see it, which you can't. It is pitch black. I don't know. Let's have a look around. Nope, it's pitch black. So I don't know, let's try to switch on the light. Good start. Pity it's going to be the worst day of your life. The light is now on. And then we get a description and we get to see what sort of objects are currently in the room. So I don't know, if I get all the objects, because I'm probably going to need them later on in my adventure, I can't do that because I'm still in bed. Oh, right, okay. So why don't I stand up? This is very difficult, but I manage it. I seem to have a hangover by the looks of the descriptions and the text that's coming back. Okay, let me get all the things. And what have I got? A telephone, a screwdriver, a toothbrush, and a gown. Okay, so why don't I put on the gown? Because that's what Arthur Dent is famous for, wearing a gown. I wear a gown. And if I examine the gown, this might tell me something a bit more about what it is. So the dressing gown is faded and battered, clearly a garment that has seen better decades. It has a pocket which is closed and a small loop at the back of the collar. Okay, that pocket looks interesting. So let's open the pocket. Okay, something my aunt gave me, buffered analgesic, that'll be good for a headache, and pocket fluff. So I don't know, let's take the tablet. I swallow the tablet. After a few seconds, the room begins to calm down. Okay, my headache has gone. Okay, so let me have a look around again. Where are the exits? A small bedroom, wash basin, near the exit heading south. Okay, so I type S to show that I'm going south. I'm now in the front porch. This is an enclosed front porch, blah, 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 blah. And on the doormat is a pile of junk mail. I've learned by playing adventure games, it's best to just take everything. So I'm going to get all, because you never know when you might need it. Okay, I gathered up the pile of mail and let's step outside. Okay, so this is where the actual book picks up, isn't it? It's where Mr. Prosser from the local council has a bunch of bulldozers and he wants to knock down your house. So I don't know, what can I do? Blah, 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 blah. Why don't I lay down in the mud? So I don't know, let's try and lie down. That's better, I can't speak English. Okay, so you get the idea. I type something and things happen, okay. And it's quite good fun as well. So that was a single player text-based virtual world. But soon after the appearance of such games, some university students in the UK invented MUD. A MUD is a multi-user dungeon, and it's a multiplayer text-based adventure game. A little bit similar to the one that we've just seen. And the video that I'm playing at the moment is of an interaction on the original MUD that I recorded a few days ago. In it, you'll have seen that I've just finished chatting with a wizard called Pywacket. And at some point through the video, I come a cropper with some rats. You can enjoy that as I keep talking. But the thing about these sorts of adventure games or MUDs is that they are low tech. So I've actually connected via Telnet, believe it or not, although proper clients are available. It's quirky, there's humor, imagination, playfulness, but sometimes it is serious. It's literary, so there's a narrative there. There's a sense of place and time and genre. And in this case, we're in a fantasy world, although we were in a sci-fi world with Hitchhiker's Guide to the Galaxy. And actually, it's a lot of fun. There's also many varieties of MUD. In the mid-1990s, when I was at university, I would play on something called Moo. Moo is an acronym for a multi-user dungeon that's object-oriented, M-O-O, Moo. And in a Moo, what's interesting is the textual world is a collection of user-generated objects. Users program the behavior of the world as well as inhabiting it as well. It becomes an interactive development environment. And that's in contrast to the mud that we've just seen, which has been programmed by someone that everybody collectively plays. So muds and moos became very popular. Before all the toxic aspects of current social media platforms, such behaviors were sadly manifested in these virtual textual worlds, and most famously documented by Julian Dibble's A Rape in Cyberspace, which I highly recommend. It's a very thoughtful piece. Yet at the same time, these were progressive places, and I made many friends all over the world at a time when such things were still viewed with incredulity. Social scientists, psychologists, literary critics, artists, and educators all got interested in these platforms. MIT professor Sherry Turkle famously analysed such online role-playing as a way for folks to explore different aspects of their identity in a relatively safe manner. The challenges that may arise in such platforms would allow folks to reflect upon their behaviour and get to know more about themselves, a sort of narrative development of their lives. Now, being British, I spent most of my time asking my fellow players what the weather was like where they were, be that San Francisco, Paris, Tel Aviv, or Singapore. This, for me, was strangely satisfying, and it made me feel like a true citizen of the global village delivered via the information superhighway that was my 56K modem in the 1990s. I also built a textual, interactive representation of a remote Scottish island that my girlfriend, now my wife, and I visited over the summer of 1995. I still have a backup, and it's an interactive digital memento of my 21-year-old self. It was, and it continues to be, fun to write, explore, and interact within such worlds. This all feels very low-tech, but I like that. I don't miss the transactional and manipulative nature of the current state of the art. And the focus is definitely on being in a specific place, in a certain moment, with particular sorts of people. The things I love about MUDs are that they are, well, tell rather than show. The user's imagination is paramount. And this is reflected in the simple and uncluttered user interfaces where the text is most important. They could be playful or serious, but always tell a story within a recognizable literary genre that sets the scene for interactions between users. Whereas graphical games focus on hand-eye coordination and showing us things, text-based worlds put narrative, meaning, and intent at the center of their process. And while the reader may have more to do with their imagination, I believe the reward is far greater, for what you imagine will always have the best special effects. Literary worlds are also more egalitarian and accessible. They're within the realm of a single developer. So there's very low overhead in technical terms. This to me reminds me of the difference between making a movie, which requires thousands of people, or writing a novel, which, whilst still an onerous task, is something that a single person is able to do. So I asked myself, what would a MUD or a moo written in 2020 look like? Well, as it happens, I'd already answered this question. Pi Week is a game jam for Python developers, and it's organized by the amazing and hugely talented Dan Pope. It's a wonderful hidden gem of the Python community, and I would heartily recommend that you should try it. It's a very friendly place, and it doesn't matter if you've never written a game before, you'll have a blast. I've had a wonderful time. And in 2019, with my buddy, Andrew Smith, I entered as a team. Andrew is an author and a journalist, so we wanted to do something text-based. And the theme that was given for this Pi Week was 6 worlds. And we decided to create a simple Moo-like game where folks could build things, add behavior via a Lisp-like scripting language, and interact with each other in the style of 6 different literary genres. Jane Austen, poetic passions where everything had to rhyme, hard-boiled detective novels, something we called JRR fantasy, sci-fi and future worlds, and of course, something that we called Parry Hotter, so that we wouldn't infringe somebody's copyrights, but you get the idea. However, TechSmith was born. but it was written in a week of furious coding. Note the minimal book-like user interface, and the focus was definitely on creativity, exploration, a sense of place, and genuine textual interactions with others. This was incomplete, but folks could make objects, and we had the start of a Lispy scripting language to make the world come alive and programmable. The video is a short exploration through the world. It's browser-based with WebSockets handling everything in the background. And while familiar in modus operandi, the user is moving between places and meeting other users, we've added a multimedia spin to things too. As you can see, there are pictures, and you can see I'm just about to start some audio, which obviously I've not captured in this particular video. It adds to the atmosphere. I'm almost tempted to think of this as a multi-user social Jupyter notebook. And of course, as we interact with the game and say things and so on, it looks as if it's a printed word. This is important for us too. We're focusing on the text. Happily, we came fourth in the team category, which is our best result ever. Woohoo! And folks appeared to like it. The idea for this is unique. This has great potential. Really cool entry. Really would have liked to see that scheme-like scripting language mentioned in the help text. I think it would have pushed this over into extremely cool no matter what territory, and also would have inclined me to play with it way more. So I set myself a mission to finish TechSmith. I'd had so much fun that I couldn't stop reading about MUDs or coding on TechSmith. My desire to write, create, imagine, play, and explore fueled my enthusiasm, as did my growing dissatisfaction and unease with the current state of the art for chat or text-based interactions on the internet. Since the UK, like everywhere else, was in lockdown, I decided to entertain myself after work by rewriting TechSmith properly. I had to turn a week of hacks into something that I would like, I could share with people. It has full test coverage, docs, a scalable architecture, and so on. In other words, code I'd want to show the world, like here at EuroPython. And I did my research, which was remarkably good fun. Starting at the top, Designing Virtual Worlds was written by Richard Bartle, who created the world's very first MUD. And it's a sort of a Bible, really, for those people who are interested in this sort of thing. And it's also a cracking good read. I highly recommend it. A Theory of Fun by Rafe Costa is also very good. And it's actually cartoons and writing. So it's a playful sort of a book. And Rafe has been involved in an awful lot of massively multiplayer online games in his time. My Tiny Life by the aforementioned Julian Dibble is a good historical context about what was going on back in the 1990s in these text-based worlds, and contains not just the infamous or famous Rape in Cyberspace paper, but many, many more that deals with different aspects of how people communicate and interact and build and make things in a digital world. If you remember, I mentioned Moo as being a type of MUD. Well, the original Moo, called Lambda Moo, was created by a chap from Xerox PARC called Pavel Curtis. And so I managed to find a version of this online, still online, the Lambda Moo Programmer's Manual. And this was a great technical inspiration for me. And then finally, there's GetLamp, which is actually a documentary, a Creative Commons licensed documentary about adventure games and this sort of genre. It also looks at interactive fiction and things like that. And if you're interested in finding out more about these resources, and if you're interested, I hope you do, the slides for this talk are linked from the page for this talk on the EuroPython website. So you'll be able to come through and follow the links yourself. This was all remarkably good fun. So how does the revised TechSmith add up? What parts become the sum total of TextSmith? So let's look at our little diagram here. At the top is basically the front end. At the bottom is Redis, which is the data backend, and in the middle is obviously the middleware. Let me take you through each of these aspects of the platform in turn. So starting at the top left, Quart is an async IO web framework a la Flask. In fact, the API is exactly the same. And this is the thing that provides WebSocket support and the website for TextSmith. Now, Phil Jones, who's the maintainer and creator of Quart, does an amazing job. And I have to say, put it on record, that this has been an absolute joy to use. So if you are familiar with Flask and you want to do some async IO sort of development, Quart is definitely the way to go. Of course, output to the user is framed within Ginger templates. That's nothing out of the way about that. And then we get to Babel for internationalization. And this slots really neatly, due to a Flask plugin, into Quart. So TextSmith is fully translatable. Text-based virtual worlds are not just English virtual worlds. And I want my code to respect and acknowledge the diversity of folks who may use it in whatever language they might want to use it in. The middleware of the app is all Python async IO, and I use some really wonderful libraries to help make this easy to code. If you look on the right, structlog, I'd like to point out, is a really helpful way of letting me see what the application is doing. It emits structured logging using the 12-factor app scheme for web apps, and it's just slotted in and it worked perfectly. So thanks, Heineck. And the other async IO related libraries for things like connecting to Redis, processing forms, working with email and things like that, they just worked for me. And I was a bit cautious about using async IO because I know it's perhaps the ecosystem with async IO is perhaps not as mature as other places in the Python ecosystem, but everything just worked for me, which is a real great joy in terms of coding. On the right-hand side, you'll see a gentleman that might look familiar due to keynotes at previous EuroPythons, a very sly-looking Dave Beasley. Sly stands, it's one of these three-letter recursive acronyms. Sly is a Lex Yak thing. So Sly, Lex, Yak. And this is a module that Dave has written that I use to process the nascent Lisp-like scripting language used by players to create the behavior of the textual world. Dave's work has been a fun way for me to learn about the language design and learn about language design and implementation and all that other good stuff, which is a part of computer science that I'm not that familiar with. I'm actually a classically trained musician, so I don't have a computer science degree. So this was great fun, but there's still lots of work to do on that front. And finally, Redis is used as an object store, where Python dictionaries become JSON objects stored against a key. Redis is a fantastic key value data store with a host of simple yet powerful features. I've been very impressed with it so far. It also comes with a message queue that's used by TextSmith for inter-object communication. For example, if a user, an object, says something in a room, another object, then a message from the user describing what's been said is sent to the room via the message queue. Then the room itself will send messages to objects representing other users in the room, telling them someone has said something. It is these messages that the users receive saying, you know, Fred has said hello, that are sent to the user's browser via the WebSockets. TextSmith is also designed to be scalable as well. So you can have as many Python instances of the application as you want because they scale horizontally. And all the interactions between these nodes, as it were, are through the Redis message queue. And of course, at the back is a Redis cluster sitting behind all this. However, you could just always run this as a single app with Redis running on the same box. So how does it work in terms of working with the user? How is user input handled? Well, we have the following workflow. We escape any HTML in the user input. That's very important first. Then we handle special shortcuts that allow people to say things, shout things, emote things, or say something directly to a person. if the input doesn't match that. We check if the first word in the sentence is a built-in verb like get, drop, build, and what have you. And then we pass on the handling of the rest of that message to the built-in function within TextSmith. If that doesn't match, we break the sentence down into grammatical parts: the verb, the direct object, the preposition, the indirect object. I'll come to what those mean in a second. Then what we do is we match the verb to an attribute name of objects in the room, and we do that with a sort of order of precedence. So we check if the verb is an attribute of the user. If it's not, we check if the verb is an attribute of the room, and then the direct object and indirect object if they exist. And then we place that attribute value in the necessary message queues. Now, if the value of that attribute is a string starting with #bang, we evaluate that as a script. So, for instance, if the whistle object has a blow attribute with the value the whistle toots, then the command blow whistle will result in the whistle toots being displayed to everyone in the room. The verb blow was matched against the whistle object, and therefore the value of the attribute blow was displayed. So let's just have a quick revision of grammar from primary school. If we have the command stack treasure on table, the verb is stack, the direct object is treasure, the preposition is on, and the indirect object is table. Now, of course, this changes depending on the locale or the natural language that the user is using to interact with TextSmith. And this is something that we need to handle ourselves. So I mentioned script and the scripting language. It's a very simple Lisp-like thing. How does that work? Well, it's definitely a work in progress, I can tell you. But scripts are evaluated in a particular context that contains the following things: the user who gave the command, the room in which the user finds themselves, the exits from the room, the other users in the room, things, other objects in the room, this, which is the object that matched the verb, the direct object and the preposition and indirect object if they exist, and of course the raw user input. Scripts must complete within a certain period of time so we don't hold up the game or report that they've run out of time. Scripts may also only update objects within the context that they find themselves in. Scripts execute with the privileges of the user who caused them to run. So if a script tries to change the description of an object that I don't have permission to change, then the script will fail. And script may only emit messages to object in its current context as well. And of course, if the script fails, users get a meaningful error message or a stack trace. And that's just the user who tried to run the script. Of course, the last thing we want is to fill a room full of stack traces. So that's essentially how the script works. What's the current status of TextSmith? Well, TextSmith is, I estimate, 80% finished. I'm having fun and speculating about how people could creatively connect with each other through code that promotes a space for playful or serious interactions. But as they say, I've only got the other 80% to go. Now that's doubly so in this case, because that other 80% is going to be the worlds that are built within TextSmith. So we're coming to the end now, and we'll have a bit of time for questions in a moment. But all of this makes me think of nested textual systems. And those of you who've read Gödel, Escher, Bach will see where this is going very, very quickly. There are, in essence, textual systems within textual systems within textual systems going on here, okay? So for instance, Python is a text-based programming language. TextSmith is a multi-user platform for building interactive textual worlds. And the textual world, inhabited by and meaningful to the users, is built on TextSmith, which is built on Python, okay? So it's a bit like what we can see on this slide here. We see a picture, but we also see a hand holding a ball in a picture. And we see the artist reflected in a ball held by a hand in the picture. So it's kind of not turtles all the way down, it's abstractions all the way down. So in conclusion, technology cannot, alas, of itself stop folks from being rude, thoughtless, ignorant, or intolerant. But that shouldn't stop us from trying to imagine and create technology that emphasizes our humanity, autonomy, and promotes mutual respect, tolerance, and compassion in a diverse and cosmopolitan society. TechSmith is a goofy game. TechSmith is also a kind of a thought experiment in code. But most of all, it's a multi-user collaborative development platform for creating and inhabiting interactive textual and multimedia literary worlds. All this without transactions, analysis of your social graph, manipulation of your attention, or clickbait adverts tailored to your user profile. You can find the code and the docs in the links that are in the current slide. And for those of you who are interested in finding out more about MUDs and MOOs and all that other good stuff, I highly recommend the Titans of Text podcast. It's US based, and that's great fun. They get all sorts of people talking about interesting MUD and MOO related things there. And it's also at times quite thoughtful. There's also the Mud Coders Guild. I'm not the only one doing this sort of silly thing. There's actually a remarkable amount of people doing this sort of a thing. And I was really pleased to find this place. They have a Slack channel and there's some really stimulating conversation going on there. And there's also a multi-user dungeon server on Discord as well, which of course you'll need to find, you'll need to get in an invite for, but you could probably get that through people in the Mud Coders Guild. So, I'm pretty much on time, I guess, for a few minutes of questions. So, are there any questions? Thank you very much.
Thank you, Nicholas. You are on time indeed. So just a reminder, if you want to drop a question, use the Q&A function on Zoom. So we have a question from Thomas.
Yeah.
You said it is translatable to other languages. Does that also apply to the grammar used to analyze sentences?
I knew I'd get a question about that. Not yet, but the mechanism is in place. So I'm writing this, obviously I'm an English speaker and I'm writing this with English in mind, but there are certainly going to be stubs. Well, you can see even now there are stubs in the code where it is doing the equivalent of a case statement, I guess, a switch case statement that's working out what the user's preferred locale is, and it will analyze the grammar in the appropriate sort of way. Error messages and things like that are also translatable. You'll see that all the strings in TechSmith are Babel translated.
Awesome. Reese is asking, what's your take on VR being applied to MUDs or MOOs?
So I'm assuming you mean graphical presence in a virtual space. I think it's great fun. My son has an Oculus thing, whatever it is he wears, and he likes using that and playing games and things like that. And he tells me that Firefox have some sort of Firefox Labs type thing that will allow him to be present with his friends who also own the same model of device. They've not figured out a standard yet. That's yet to come. I mean, that's interesting. It's like Lawnmower Man, another reference to the 1990s there. But I like text. Call me old-fashioned. I like the fact that I can let my imagination fly, and text is perhaps the best way of letting that happen. And the thing about MUDs is that because it's not just transactions of conversation going on, there's a place, there's a sense of traveling around, there are objects, there are ways to sort of interact with players as well in a non-obvious way. I missed out a whole section on some of the stuff that Julian Dibble mentioned, some of the innovations that we still don't see in current text-based systems that were sort of invented and used in MUDs and MOOs in previous decades. So in a sense, they're also at the very forefront of technology and waiting for folks to catch up. So I don't know, VR's cool, you know, I like space rockets and flying cars in that sort of a way, but I also like reading books and text-based things too. I hope that answers your question.
Cool. Dennis asking, are there new challenges to creating MUDs in 2020 that were not present in the 90s?
I'm tempted to say, yes, our development environment and the cloud and Kubernetes and Amazon and all of that sort of stuff. Because in the 1990s, this was a single server, you know, a server running on a single box that usually had a host name that somebody, you know, it was their pet rather than cattle, to use the terrible analogy that cloud uses. And that in itself is kind of cute. Whereas, as you've seen, the way I've tried to organize TechSmith is as a modern web, dynamic web application as well. So I would say we've learned a lot more about how to do this, perhaps, and the tools are more available. I've got Async.io, I've got Quart, I've got Redis and things like that. So in a lot of senses, I don't have to reinvent the wheel, whereas folks in the 1990s would have to do that. Yeah, it's still a challenge because I have to imagine things, and that hasn't changed.
All right, thank you. Stanislav has a question as well. Have you tried using machine learning for generating content inside a game? I remember seeing something like this in the wild.
Yeah, okay, so that was, yes. Shh. So you're looking at maybe a OpenAI type text generation here. So there was lots of discussion about this on some of the MUD forums that I've been inhabiting over the last few months. The text generation for adventure games, for single player adventure games, like the Hitchhiker's Guide to the Galaxy thing that I showed as part of my talk, that's happened. The corpus that was being used for that sort of stuff, however, was taken from social media and things, and the quality, whilst initially it looks cool and good and things, the quality of it after a very short period of time, you get bored of it, apparently. This is what I was told by somebody who'd been experimenting in the field with that sort of stuff. I've actually been, I used a Markov chain to generate some room descriptions based on stuff that I'd been scraping from other MUD descriptions. So that all the fantasy ones, we had lots of orcs and the elves of Treflelion with their goblets of fire and all of this sort of stuff. And that was quite hilarious, if a bit meaningless. But I really like that point. And I think that there's room for lots of innovation in MUD and Mu-related engines for that sort of a thing. And I'd just like to point out that because this is text-based, making changes and playing around with these sorts of things is a relatively low-hanging fruit. If I were doing this in a graphical game or a VR game or something like that, I would have a huge code base with lots of assets, and making a change is quite difficult to do. This is just literally text comes in, I do some stuff, I put text on message queues, text goes out. That's essentially the modus operandi of this sort of thing. I hope that answers your question. That was a really great question. Enjoyed answering that.
Thank you. I have one question. I really like the idea of recording moments that you said that you recorded that moment with your wife in Scotland.
Yeah.
How would you go about doing that? Like, do you have an example?
What I have is a virtual world that I created when I was 21. And as somebody in his mid-40s now, I can return to that. And I don't know about you, but I can't remember anything about the code I've written 6 months ago, let alone back in the mid-90s. So it was fun to inhabit what was in my head in a textual sense from 20 odd years ago, if you see what I mean. So I've got, it's a bit like, it felt to me a little bit like reading my diary from way back when, but this was an interactive diary, and there were objects in the world, and I could, there was a photograph object on the mantelpiece object. And so I could look at the photograph and I could see the description, and it was a photograph of my wife's dog, who was now passed away. I'd forgotten about Jeannie. I was like, oh gosh, I remember Jeannie, and it brought back a flood of memories. So, so that's how it felt like. Is that helpful?
Yeah, yeah. It sounds like it's just like it's the structured journal, right? Where
Yes.
you, right. Yeah, sounds good.
Yeah.
Awesome. There's no more questions. Thanks, Nicholas, for the great talk.
Thank you. You're welcome. I'll stop sharing and get out of here. Thanks a lot.
No worries.
Take care. Ciao, ciao. Bye-bye.
All right, so we are in a break now. We'll be playing some ads, and yeah, I'll see you. I'll see you after lunch.
Ads. Oh my God.
Well, we have sponsors, right?
Yeah, I know. I just think it's great given the content of the talk.
Oh, true. Okay. So I'll see you after lunch. Bye. Hello? Roberto, you're there?
Hello, Jill.
Hello. How are you, Roberto?
I'm fine, thank you.
I can't hear you. I don't think you turn on the camera.
Yes, I turned it on, but it seems that the image is
Maybe it's the wrong
frozen.
camera.
Excuse me?
Maybe it's the wrong camera.
No,
Zoom.
Yes, please.
On the video, there's an arrow up. You can pick the camera. Oh, there you are.
Yeah, I just did nothing.
Okay.
It was just a frozen camera. Now I will start sharing the screen.
That's fine. Yeah, cool. So where are you zooming from?
Well, I am from Italy.
Ah, nice.
And we struggle to move on in these hard times, and I think that we did quite better than I expected, and so I'm quite happy about how we managed to face this particular period. And for me, with 3 kids, was not easy to manage the remote lessons.
Yeah. All right. So do you want to start now?
Well, I'm just finishing the setup. Can you see the?
Yeah, I can see your slides. It's not full screen, but I think that's fine. So okay, we are in the knee
I will
track.
try to full screen the slides then.
Yeah, try that. It's not a problem because I can see most of it. Oh yeah, perfect. Cool. So I'll introduce yourself. So we are in knee, and Roberto is going to talk to us about extending HTTP for fun and non-profit. Oh, the window is getting smaller.
Hi, everybody.
So yeah, give him a big hand. Perfect.
Hi, everybody. I am Roberto Polli from the Italian Digital Transformation Department. My work is to create a national API ecosystem that is capable to connect public and the private sector. And another of our goal is to provide cross-border services with the other European Union countries. And today I will present how, while writing the Italian API guidelines, we started contributing to the HTTP protocol. So the agenda is the following. After a brief rationale about using API guidelines to achieve goals and results, we show how you can create a minimal feature landscape for your guidelines and identify relevant standards and communities to interact with. Then the strategy will be presented using 2 case studies. The first one is about writing an internet draft that extends HTTP, starting from an old specification, needing a refresh. And the second one, where we wrote a brand new specification from scratch to cover a use case that was not covered before.
Sorry, Roberto, the window is pretty small, so we can't see most of it.
Can you see?
I can only see,
you
like,
cannot see the the whole slide.
No, not the whole. It's like half.
Okay, so I will
try to remove from. Yeah, I think that's good. You don't need to put it on full screen.
oh,
Yeah. No,
mm,
that looked good.
okay, well that's not okay, is that better?
Yeah, that's good.
Okay.
At least we can see the whole slide.
Okay. So which is the goal? One of the goal of the Italian digital strategy is to uniform the APIs produced by the all Italian agencies. And this is quite challenging because we have, 60 million people, more than 20,000 public agencies, 8 cities, 20 regions with some autonomy. And to be able to create a uniform environment for software produced by all those slides was not easy. The solution we found is to provide guidelines so that every agency should produce APIs following those guidelines. Well, when you write guidelines for the public sector, you have some risks because technical specification in government risk to mimic a bureaucratic environment. So you can have over complexity because bureaucratic non-digital processes are just converted to convoluted APIs without a good redesign. You have time constrained engineering because a small group of people should address complex use cases within a short deadlines. Many times you have a closed development environment because the IT community is rarely involved, and sometimes you have even closed specification. And then redundancy, because you are building stuff with existing standards, but you are not keeping in touch with the original communities. So maybe you start to customize the behavior of some specification, you start customizing protocols without asking for feedback from the original communities. And this is quite risky. So when you write guidelines and you have to write something that should be followed by thousands of implementers and suppliers, you have to prioritize your goal and features. When you prioritize your goal and features, it's easy to identify the stakeholder and the feature landscaping. You know easily which are the people you have to talk and who you need to ask for and who you need to keep in touch. So about the goals, we found essentially 4 goals. The first one was a consistent design. We wanted that all the APIs produced by the agencies had a consistent design and were based on a consistent rule set. And another one, very important, is schema standardization, because when you have to create an ecosystem, you should rely on standard schemas and the meaning and the semantic of every field and of the objects you use should be confrontable. For example, if you use a person schema, you should name the fields in a consistent way. You shouldn't use different fields for the same element, and you should split fields in a consistent way. For example, if you split always name and surname, every agencies should split name and surname and shouldn't mix up those fields. Another theme is reliability and security. We wanted to enforce a service management model to address cascading failures, and we need the security frameworks that lower the legal risk for providers, because if you don't have a consistent set of security rules, agencies won't just provide API because they will be afraid of data breaches. They will be afraid of falling on some GDPR regulation and data protection issues, and then they will just avoid serving citizens. And all this stuff should be done engaging and creating communities, both in government, for developers, for between implementers and standards. So let's see a simple example. Consistent design schema, reliability and security. Let's make a grid. Start with 4 rows. Those are our preliminary goals. You can use your own. If you are planning an ecosystem, it is both valid for if you work in a company, in a private company, you can follow the very same framework. So pick your goals, and then on the columns, identify the relevant communities and technologies. For example, for the schema, for the design, for the reliability, we always have to confront with all the national agencies. We will keep in touch with other European countries and check. Let me see if your schemas for personal data are the same of mine. Which are the different? How do you implement security features and so on? This column, the third column, is the one on which we will focus today, is the standard one. These are the column with IETF community, the World Wide Web Consortium standard communities. And here we will put all the information and all the relevant standards that we are going to use to provide schema, design, reliability, to achieve the schema, design, reliability, and security goals. Finally, we have communities. One community can be the Python communities, for example, but there are many other communities that could be interested and works on security, for example, on design, on schemas. And another one, we have vendors communities, because if we have to provide features that people have to implement, we will have to get feedback from vendors, and this is very important. So again, those are the main communities we identified, but sure, in your context, in your framework, you can pick your own communities. And then let's start to fill all the cells of the grid with standards. For example, for the schemas, we decided to use, between the others, those standards. The first one, RFC 7807, is JSON problem, is a standard JSON schema for managing error and issues. Then we have a standard for timestamp. We have one for currency codes and languages. We are using J. So just write down all the relevant standard that you are going to use or that you are interested in for your API ecosystem. On the design, we relied heavily on the standard, the latest HTTP specification, that is RFC 7230 and over. And another interesting community and specification is the OpenAPI specification. On the reliability, we based everything on the HTTP with a REST approach, but now we found a missing feature. In the standard HTTP, you cannot find enough specification to provide an integrated service management environment for such a large ecosystem. So we just noted that we had to work on that and keep in touch with communities and investigate. Again, on security, we had similar issues because there are many specifications. There is the digest header, there is JSON Web Token, JOT, and so on. But there are even draft standards that are not consolidated. And still, there is not a non-repudiation framework. So in HTTP, with a REST approach, you don't have a very tight framework to define a non-repudiation protocol. And well, on the other column, the communities column, we have a set of communities we engaged with during this work. For example, on the security stuff, we discussed it between IETF, W3C, the HTTP communities, and the banking API communities that was very interested in such features. So we now have agreed on the strategy to gather and get all the interesting technologies, relevant technologies, where we can find the missing blocks. So let's start for the first use case. We started the first use case and we started proposing solution. We research and analyze actual solutions, even if not standard, and we include in our study experimental work and research papers. We wanted to achieve, as we said in the slide before, a non-repudiation framework based on HTTP. We identified the various building blocks for building such a non-repudiation framework. And we focused on the simplest building block that wasn't completely covered by standard specification. This was to ensure the integrity of the payload body of HTTP requests and responses. This was usually done with the digest specification, with it, but this specification it's not very used recently. So what did we do? We started engaging with the community, and this gave us a series of unexpected outcomes. We found that many implementers didn't use the digest header in a proper way, and this was because this specification was quite old. And we then started to keep in touch with implementers and other HTTP experts, and everybody said, okay, the digest could be a suitable solution, but it's quite old and somebody should just rewrite it. But nobody has the time to do it. Then I volunteer for this kind of work, and I draft a standard solution. I rewrote all the digest header specification. I found Cloudflare employees that helped me in this work, and we rewrote almost everything, adding details and fixing loopholes. We looked for people to help us. We spoke with suppliers and vendors. We got feedback and awareness from many implementers. And then when we thought that everything was quite good, we got back to the IETF, and they said that they liked our work. And this resulted in the adoption of this specification. Now that I was inside the HTTP work group, I learned a lot. Even on matters that I didn't know before, and this helped me in improving our guidelines, even on subjects that were not expected before. Then we continued to contribute to the draft and to other specification, and we will do it until the digest internet draft will obsolete the old draft and become a new RFC. So the trick here was to join the community, not as somebody which wanted to get something from the community, but as a volunteer for an housekeeping work, for something that everybody wanted to be done, but nobody had the time to do. Here we can see the digest header draft. This draft provides a content integrity for various API, included banking ones. Now it is widely used in conjunction with signatures and has now been adapted to the latest HTTP specification. It has better security consideration covering signature usage and clarify a lot of ambiguities. In all these paths, we learned a lot. So it was not just something that we did to push our use cases inside HTTP, but it was even something that we got from the HTTP community that is very warm and that is full of very, very knowledgeable people. Okay. Working with the first draft, we made friendship with the HTTP community. We had the opportunity to learn a lot of interesting HTTP features. And in this way, we got social with other HTTP experts. We became knowledgeable of the IETF process. Now we know which are the steps that you have to do between the writing of a specification and the approval of the specification. We got involved in other HTTP specification that was very interesting and useful, because in this way we learned a lot about security issues we have removed and fixed in our guidelines. And even we discovered the existence of the HTTP tree and other interesting features that are now work in progress inside the HTTP work group. So with the strength of all these social relation, of the knowledge we got in working on the first specification, we decided to work on another missing use case. While the digest header was a missing use case that was based on an existing specification, the second case was we worked in greenfield because there was no existing specification on that. And this is the rate limit header fields for HTTP. When you issue a lot of HTTP requests, a server may be overloaded, and if the server gives you just a limited amount of quota of requests, you may end out of requests, and your request will just receive an error. A nice way that the server can do for you is to warn you and tell you in the response how many requests you are left. So the current landscape is that when you use API gateways, every API gateway returns this information in a different way. So there are more than 12 possible HTTP rate limit headers because there is no specification, there is no standards. The results is that many clients just ignore them and their request eventually fails. We then wrote this draft together with Alex Martinez from Red Hat, where we standardized 3 rate limit headers. It's very simple draft, but there are some complexities for the management of security of this kind of draft. And then we started working with suppliers and cloud providers to implement them. In this case, the interactions with the HTTP work group were not the core point, okay, of this specification. The core point is to manage the API gateway vendors to implement it, and then we have the Kong API gateways implemented it, the Red Hat API gateways implemented it, Microsoft Azure API gateways supported us and allowed to configure the Azure API gateways to implement these features. We have libraries that are currently implementing that. There is an API from the British government that adopted this draft. So in this work, the interaction and the communities were quite different. And then the last slide, there are some other communities and drafts and standards we are working on. Well, there is the digest headers and the rate limit headers I presented now. We worked and managed to be approved even a couple of features into OpenAPI, just like the mutual TLS and the summary metadata features. We are working inside the ITF to support an HTTP signatures protocol. We are adding metadata in OpenAPI and still continuing to work with suppliers and community to implement features that missing features that are needed for our guidelines. Well, I'm finished. I hope you enjoyed the presentation. It was short, but I tried to make it easy. Those are my references, and well, feedback welcome and questions welcome.
Thank you, Roberto. If you want to drop a question, just use the Zoom Q&A functionality, please. We don't have any questions yet, Roberto. Let's just wait for a little bit.
Okay, in case we can even continue.
Yeah, sure.
On the slide, on the talk.
On the talk channel.
On Discord.
On Discord. All right, I'll just wait a little bit more, and if not. Okay, so if you have any more questions, there's a question here from Diego. With all these different institutions, what's the main challenge for integration?
Well, the main challenge is probably the legacy and the knowledge of technology inside the institution. This is why we focused on our work with suppliers and technology providers. Because, for example, if I have products, off-the-shelf products that supports a specification, institutions can just use those products, those open source products, and they don't have to get too deep into the technology issues. So those are, I think, the main problems. And yes, and the legacy. Institutions have legacy software, legacy architectures and there are very long times for dismissing and renewing institution architectures.
All right, thanks, Roberto. Give Roberto a big hand.
Thank you.
You can imagine the crowd going wild. So, thanks. I'll see you later then.
Thank you. Right. Thank you, Jill.
Now we have a little shout from our sponsors.
Energy is part of our daily lives, but do you understand where it comes from, how it's transported, bought, sold, and the software that powers this? That's where we come in. Join the team developing the energy solutions of the future. Trayport, where talented people never stop innovating.
Okay. Ruud, did I pronounce your name correctly? Is that Ruud?
Well, it's Ruud.
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 Yeah, okay, cool.
Okay, that's a difficult name.
Yes, for me it is. So are you ready to start presenting?
Absolutely.
Where are you joining us from?
I'm joining from the south of France, the Southern Alps.
Oh, nice. How's the weather over there?
Super, just sunshine every day. It's really it's wonderful here.
All right.
So, shall I start?
Yeah. So, give Ruud a big hand. And yeah, go ahead.
Okay. Well, today I would like to talk about a GUI package called PySimple GUI. Let me just show my interest, why I'm interested in PySimple GUI. I had some experience with animation, quite technical in TK Inter, because I have a kind of simulation package. But then I also had some project that could use an attractive GUI. And my first idea was then TK Enter, but it's kind of tricky. And then I had practically no experience with those GUIs. And then I got into contact with the sole developer and maintainer of this PySimple GUI package through a forum I join regularly. And I thought, well, this is a good start. And but you have to remember, I'm not really a GUI expert. I just wanted to show you what I found, and I would do some live coding, just building one or two small projects. So what's on the menu? I will give you a very short overview of the GUIs in the Python landscape.
Sorry, are you sharing the screen?
I'm trying. Sorry.
Yeah, it's okay. I wasn't sure. That's why I didn't ask before.
Oh, maybe here. Can you see it?
Not yet. It's all black still. Yes, that's Discord.
Yeah, okay, well, there's no problem. We'll just go to, sorry.
No, it's okay. I should have asked before. Awesome.
Okay, well, you just missed the first two slides, but you heard me already, I guess. So what's on the menu for today? Just some short introduction in GUIs. What is PySimple GUI? I want to do, if possible, 2 sample applications. Show you a little bit of what PySimple can do with the work from others. Some pros and cons, and then a conclusion. So why GUIs? Well, they're important because, well, if you just have a text interface, it doesn't really work. It's complicated, and just for even for simple tasks can be already very interesting to have the a pretty interface. But GUIs are usually quite complicated. They take time to set up, and you have to know a lot of things. And that's why it's sometimes not very attractive to start with that. So, for instance, a very small GUI, more or less a trivial thing. We have the input function. So we just ask for a number and another number, and they just add it up, and then we have and then up to a certain time. Well, this is not very attractive, of course. There's absolutely nothing there. Another example of a non-GUI application is a command line interface. For instance, Black, the formatter. If you want to run that one from the command line, you have a number of options, and you have to remember all the formats and all that. So it's also not very attractive. It would be nice to have a kind of interface for that, and we're going to work on that soon. What's there in the Python world? Well, one of the most obvious is tkinter, which comes standard with all or most Python installation. Has a lot of features, maybe a bit old-fashioned, but it's very flexible, but has a high learning curve and a not very intuitive API. Just to show you that here's just a very small example of an application asking for 2 numbers to add them up. But there you have already quite a lot of code, and not that obvious. You have to do something here to define a route, but you have to start a main loop, something with grids, and there's callback options. So this is not that easy actually to do. I'll show you the same applications in a couple of minutes in tkinter. Then there are other GUI frameworks. The most well-known are WXPython, PyQt, Skyvi, which is interesting because that's also cross-platform. But all of them has actually this quite long learning curve. They are powerful, and some of them even incur license costs. For instance, PyQt. Then there are some GUI builders for interactive systems. They're not very popular in the Python world, maybe because the interfacing is rather complex, and you have to maintain both the GUI part, which is usually then a kind of graphical interface, and the application. Some of the examples are Page and PyQt. I'm not even sure whether they're well maintained or not. So then there's an alternative called PySimple GUI, which is a relatively new project, started 2 years ago. It's extremely actively maintained, which means that there are new versions very, very frequently released. It's open source. And what's the interesting thing is that it runs actually under or on 4 different platforms. It's available on tkinter, which is actually the main branch. There's PyQt, there's WXPython, and it is also interesting. You can also make a web interface, and in principle, they have all the same API. I want to do something with the tkinter version of PySimple GUI, and therefore I'm going to switch to to Python now. So what I want to do is build this simple adder application, which has two numbers and the result, calculate button here, and we're going to build it. So start really from scratch. So the first thing you have to do is import simple GUI as G, that's a kind of convention. And then we say, see, that's also the Qt version. Then we go and define those rows, and those rows are actually just defined as a list of all the elements that are in there. So what's there? We start with a text field, and the text field is of course the title, the name, number 1. Then we have an input field. Input field. And the input field needs to be identified later. So I just have to give what they call a key, and so that's that second field. And the third field is a button with the name, with the title calculate. Okay, that's row 1. And now row 2 is more or less the same, of course. So I just say here row 2, just change the 1s and 2s. Remove the button because we don't have a button on this line. Just calculate. And then we have row 3. Well, row 3 is actually just again a text result. And then followed by another field, another text field. And that text field has to have a size because we're going to fill that later. Wait a minute, I can also do this. Easier. Then it has already a size, and then this one is a key. I have to reference to that, and the reference is then result, and that's actually it. Then I just say, okay, I want to formulate all those things, which we'll call a layout. A layout is, and that's a row. That's a list of row 1, row 2, and row 3. Row 3. And then I just make a window, and the window is actually making this whole thing. I just add a title, header, and a layout to indicate what it looks like. And then we can already test it, and I'm sure there will be some mistakes in the let me see, a window dot read. This is just a dummy. Just go and test it. What's happening? Oh, it's very slow for some reason. So we made a mistake. This is a comma. Real life conference, you always people who shout, make a mistake, but that's not possible now, I'm afraid. Windows not defined. Nearly there. Okay, well, it doesn't do anything. Here you can see actually already the whole layout and all that, but it doesn't do anything yet because I haven't defined anything. But what I'm going to replace this with a small event loop. While true, you will always, and then I just read this window, returns an event and some values, and then I just say if event is window closed. In that case, we are done. We're done, so we break. And otherwise, we just go and say event, if event is, and then you just get the name of the button, calculate. In this case, this is the only action that can cause an event. Calculate. Then we can just get the number. So we say number one is the integer of, and then we read the this field here, which is then thank you. Then we just, this is the we just say values of number one, because those are all strings. We just do the next line, same story. So now we have the two numbers, then it's just adding them up. Two, and then we just want to display them. Then you do that by window, and then I look up this value result. This is this key, this field. So I just say result dot update result. And then that should work. A little bit of luck. Yeah, so now I can just show you that it works. 10 plus 33 is not correct. No, it doesn't say that correctly. I'm sorry, it's so slow. It must have to do with the Zoom connection at the same time. Okay. Okay, then you can just calculate. It's 45. And now it's a problem here, and I want to show you something. If I just say an invalid value, then you get the value error. And then I can just show you some of the other features. Then I just say, okay, I want to check this one. And then if I get a value error, or because that's so easy, then I just can do a pop up saying wrong. And I do something extra in this round as well. I just say, okay, I want to have some nice nice color scheme. That you can just do that with theme. And I know there's a nice one called Dark Amber. And let's also just add a tooltip, just to show you how simple that can be. I just add tooltip is enter int. Yeah, there we go. Okay. Let me just, well, just do a, you see here the pop-up, and I can still run it, of course. It's not very spectacular. And if I go here over this one, you can see the tooltip. Well, this is just in 10 minutes an application built. Now I want to do something else, but this is a project. Well, this is actually much more useful. This is a kind of front end for Black, in which you ask actually for a folder, the line length, the targets, which is a kind of one of the input fields of for Black, and an output field. Well, I'm not going to do this live because that will take too much time, I think, but I could just go and open the already. This is the application. But this is not important. It's all about this part. So what you can see here actually is more or less still the same. This is that folder thing, and here at the end, I just have to make this big. The Zoom system is in the way. Oh, wait a minute. There it is then. Okay, so here we have we just folder browse. Well, then that's some command that you can search through the folders. Here's the line length, and here I do a slider. So that's this one here, this slider. Then I do just give some parameters. I do a combo box for the target version. Also with a key and all that, and then I do a text, a multi-line. A multi-line is this thing here, in which you can put whatever text you want, and there are two buttons here. So that are these two, and all these ones are actually just this one. Here I didn't use this layout thing because I did it all at once. Then there's the main loop, and the main loop is nothing more than what you just saw. If the event is Black, and then we do something which is a bit complicated, but the interfacing with the Black system, which is a process. And then let me just run this. You can see that's already quite an interesting and attractive GUI to a complicated command line. And this is, well, just a matter of a couple of minutes, of course. And here you see, well, I've got a Black theme, of course, and I can just say, okay, I want to browse. And then you get a browse folder automatically. You don't have to do anything about that. I just say, okay, I want to have a folder, and let me just do this one, and then I just select that folder. You can see that here I can just play with the line length. I can play here with the target version, and then I just say, okay, do it. Now in the background, it's running this sub process to blacken to run Black. Which takes time, apparently. The output should appear here in this window, but the whole system is rather slow. Yeah. Well, in this case, there's nothing. It just says all done. This is output from Black. All done. Two files left unchanged, and I get a pop-up here, which is just given here, and then we're done. So this is also a very simple, quickly built interface. But you can go much further than that, and that's what I want to show you now. For instance, this is actually quite easy. This is actually an example of an application I built to run on an Android phone. just also with the same PySimple GUI interface. This is something to create a lockdown document here in France. We needed that. And now I just want to show you some of the applications from the site, some interesting things. The interfacing with matplotlib, and then you can just, this is all done in PySimple GUI. You can just select all kinds of things. This is an example of a crossword puzzle. I think these are done with buttons. I'm not actually sure how this is done, but that's also one of the users who made this one. This is an interesting one. This is an application that's actually an OpenCV connection in which is actually this kind of traffic camera, apparently something with stolen cars. I don't know what it is exactly, but this is a real application that that someone made. Here you see all the different widgets that are available. Of course, there's much more available. There's also menus and everything, spin boxes, and really a lot of things. So, to conclude, well, first of all, I am by far not the PySimple GUI expert. I just know a fraction of the functionality, but I can already do quite a lot of things with it. It has really a lot of widgets and features, interfaces with all kinds of packages. Of course, there's more or less something that's given by Python, of course. It supports threading, which is not obvious. That's quite often very complicated. It is cross-platform, which means that the different versions are more or less the same, not 100% the same. And one of the interesting parts is definitely the WebREMI interface. The documentation is really super. It's a whole set of documentation with reference guides and a good cookbook and all that, better than a lot of the GUIs themselves. So it's great for beginners, that's for sure, but also experts who don't want to spend that much time, for instance, when you have a command line interface, then it's a very nice thing to do, a nice thing to have. Well, of course, it's there are prepackaged solutions, many, but customization, you can customize nearly all the calls, but still there are limitations. So you can't control everything. And something also to consider is that this package is developed by just one man. And so, well, the continuity, well, I don't know. So to conclude, actually, I want to say PySimple GUI is a very attractive package. Worth to give it a try. And I would say go to his website, pysimplegui.com, and then you will find out yourself. You can find out yourself, and then you won't be disappointed, I think. And then I would like to thank you for your attention. And well, if there are any questions, I'm here to answer them.
Thanks, Fred.
Thank you.
There is one question here from Matthew. Really nice demonstration. Do you have any recommendations on when PySimple GUI might be insufficient and you need to go with one of the more powerful libraries like tkinter?
Yeah, I think particularly if you have if there's really high end and you want really full control over all the placement of widgets, and you want to do more things with callbacks in which you have to react on all kinds of actions at the same time. This package is particularly good in the things that they defined, but I can imagine that you can't really do everything in it. But well, as I said before, I'm not really a very GUI expert, but I understand that certain things can't be done with packages like that. But I also understand that at least you can escape to the ordinary version. So if you run PySimple GUI under tkinter, for instance, you can still break into the main loop. I don't know how, but that seems to be possible.
Great, thanks. Metatax is asking, does Remy serve a web server, or is the output an HTML file with JavaScript?
it's as far as I know, it goes to REMI, and then you can see immediately the output. It's really a GUI in the web. I'm not sure how you have to have a look at REMI, and I don't know anything about REMI. I just know that there's an interface for that, and I've seen some very nice demonstrations of it.
All right, and we have another one, which is very new to Python programming in Linux. Applying this in a Linux environment, is it as simple as Windows? I guess, is this cross-platform?
Absolutely, absolutely. And actually, I think most of it is actually developed in the Linux. I'm a Windows user, but I've used it also on Raspberry Pis under Linux. No problem at all. Mac OS is okay, and so the only thing which it doesn't support, I'm a Pythonista. This is the iPad application running Python on an iPad, and there you can't use it because there's no TK Inter available. So that's, for me, is still a problem.
All right, thanks, Wood. I'm
Pleasure.
representing everyone watching.
Okay. Pleasure.
Thanks. So we have a little word from our sponsors now.
At Bloomberg, the success of our business relies on people like you who can look into the future and create groundbreaking technology, research, and expert insight to answer the world's most complex questions. We work on purpose. Ready to find yours?
Okay, Michal, is that how I should pronounce your name?
Yes, exactly.
Michal, cool. Are you ready then?
Yeah, I'm ready.
Cool. Where are you joining us from?
From Poland, like from Wrocław.
Nice.
Today we have a good weather for presenting. It's not too warm and not too cold. It's cool.
Nice.
And there is no some works outside, so screwdriver is not working, so it's fine today.
All right, okay. And what are you going to talk about?
Today I will be talking about difficulties that we can face during development of Python code. I will share my screen.
All right, so give a big hand to Michal. Go for it.
Okay, so before I start, maybe a few words about me. I have 8 years experience in Python, 5 years commercial experience in developing Python code. And today I will share my knowledge and best practices and best tools that I'm using during project development. My presentation will be divided in 3 main sections. Each of them will be covered with a small story. And first of all, we'll start with the packages that are available in Python world. We'll have a little bit about history of Python and confusions related to that. Then we will switch to the virtual envs. We will tell what are for, and some great tools that are allowing developing our Python code in virtual envs. And then we finally focus on package managers, and we will try to clarify all which are the best and what are the advantages and disadvantages of certain package managers. But before that, we have to say that the Python world packages, virtual enums, and package managers is looking like this. Because of the history, we have some old documentation that is pointing for packages that are not used. The same thing is for package managers, which is not obvious which of them we should use. And today I will try to clarify what is the right path. And I hope that this picture will be much simpler. So in the beginning, we'll start with the story related to AWS. Recently, I have a few projects related to the that were stored on AWS, and mainly I was working with Lambda, AWS Lambda functions. And before we start our work, we was choosing out of many tools how to deploy the Lambda. We could use Terraform, serverless framework, Bottle3, CloudFormation, and many other tools. Finally, we decided for Terraform. And to use Lambda, the deployment of Lambda is looking like this. We have to prepare the zip file with our Python code, and we also have to add the libraries that we are required for example to communication with database like SQL Alchemy, because AWS Lambda itself contains only base libraries of Python. And during development, we noticed that we have a problem that Terraform is constantly building our code on Lambdas. And the reason of that is was using different wheels, because in the beginning we was doing this by hand, and each developer was using different platform. And what is wheel I will tell within few slides. And also I will tell how we fixed that issue. But let's start from the beginning. We have Python files, and we can share them between community. For example, in Bottle Web Framework, it is possible to create small web page for deployment, and we can just share this file. But it's not convenient to use that. We have to use something more convenient and reliable. And first thing that came across is a source code. And for that, it is just simply the archive that is containing the Python code. It may contain other source files like C source files for CPython. We can define there the scripts that will be available for our terminal. We can define, of course, README, the setup or setup CFG. I will tell a little bit about setup later. And also we can define some external packages, package data, like, for example, the trained model of artificial neural network. And of course, metadata to know what exactly we are, what we have installed in our system. And here we coming to the conclusion that each time we will want to use that, especially if we have the C source files, we have to compile that. And this takes time, and we would like to have the instant package that will be ready to use, and and this can be offered by binary packages. The first approach was X in Python. They was introduced with the setup tools in 2004. There was no need for building or compilation. It was a distribution format and a runtime installation format. And the first approach of listing what we have installed in our system was an info directory where we had all necessary informations what we have installed in our system. The funny thing about X, it was possible to install many versions of certain library, and of course it was possible to import directly the egg. So what was the problem with them? There actually wasn't official PEP for that, and each package manager, package maintainer has its own directories inside X, and we in Python community we had to make something with that and make some standardization, and for that wheels came across, and this also is a binary format. It was introduced in 2012 together with PEP 427. With wheels, we have also standard for distribution of the wheels and standardization of the metadata. So instead of egg info, we now have the different directory that is contain different metadata, and this is the current standard for building the binary. Wheels are not containing the Python bytecodes, but may contain other precompiled code. For example, for CPython, some C libraries. As I mentioned, instead of egg info, it is used this info directory, and the very big advantage of wheels is that they are versioned. They have the name convention. In the name, we can find the Python version that is supported, the certain implementation, because the Python can have different implementations. Also, there is information about application binary interface, which is different in Macintosh and Linux and Windows, and for which system architecture is built certain wheel. For example, Intel and AMD or other architectures, and of course, whether it's for 32 or 64 bits. For now, some wheels are importable directly, for example, for our rep, but it's not supported by PEP 427 itself. And here we can see the example wheels. The first is a universal wheel of the pip library, which is for Python 2 and 3. And this is example or one of the NumPy wheel, which is for CPython 3.6, for Macintosh 10.9, for both Intel architectures, 32 and 64 bits. currently, there are no builder on the PyPy. The maintainers just have to create all necessary wheels. We can create our wheel by this command. But there is a great talk about wheels by Elena Hashman. If you want to know about application binary interface in Linux, the ELF format, and how they are maintained and built, you can just watch it by clicking on the links provided here. And she's also supporting two projects, the Many Linux and Unedited wheel. The Many Linux project is actually the group of the most popular Linux distribution in Docker that are building wheels for this certain distribution. And Audit wheel is a command line tool that is used for checking whether this wheel is proper for certain distribution and nothing is missing. So if you want to know more, just click on the links. And this is at the end of the first section. We'll move to the virtual envs. Oh, okay. One more thing, just to show how the package is built. In the most deep layer, we have the standalone module, which are Python file. If we have more Python files, we can have a source code. And about that, if we compile that, we have the wheel for certain platform. So this is the summary of the packages, and then we can switch to the virtual envs and next story. During my journey of the development of the Python code on the studies, I have many projects, and I installed Ubuntu on my laptop, and I started developing many projects at once. I started installing many libraries to my global system Python, and I noticed that suddenly I noticed that such picture like here. And the problem is that when I was developing and installing many packages, I reinstalled one very important dependency that was used for graphical engine of Ubuntu, and I had to reinstall everything from the scratch. But it was very quick lesson for me why we should use virtual env. So what is exactly the virtual env? It is isolated directory where we have all necessary libraries and Python, which is completely isolated from the global system, which is good. And we have few tools to do that. One is the built-in tool virtual env, which is refactored now. There is a great talk we had it today by Bernard Gabor, rewriting the virtual env. I fully recommend to see this talk. And together with virtual env, there is a useful thing to use the virtual env wrapper, which provides useful commands for creating virtual env, deleting it, switching between them, and it is easier to develop the Python code with that. How the virtual envs actually working? They are putting the path of the certain and virtual env in the directory to the path before the global system, and every time we are typing the Python, it's first looking in the virtual env, not in the global system. From today's presentation, I've heard there will be possibility to create virtual envs for different Python versions, which is very good, but they must be installed on the system. They must be present for virtual env. So in Python world, we have many implementations of the Python. We have the main Python in CPython, which is written in C. We have a PyPy, which is written in Python. We have a JSON, which is written in Java. We have an IonPython, which backend is written in C#. We have a MicroPython, which is used for certain embedded systems. And we have the stackless Python, which is not containing the stack. And if we, for example, want to develop our library and test it against many versions and many, let's say, distributions of certain Python, we have to have this certain Pythons installed on our system. And there is a tool that is doing this, which is called PyenV. There is possibility for installing many versions of Python, many implementations of Python. It is offering switching between them. There is an automation of switching between certain virtual envs. It is creating the virtual envs. And here I prepared very useful command that can be used with PyenV. But before that, I just want to tell you that the installation of PyenV is very simple. If we want to install it, it just can be done by the script provided on GitHub, which is called pyenv installer. If you don't trust this this script, you can use the you can do the command one by one in this script. And very important thing, you have to install dependencies that are required for compiling the Python versions. And there is all dependencies accordingly to the distributions, which can be found here in the frequently asked questions. And be aware of that. If you want to, for example, use the JSON, you have to have the Java on your machine. If you want to use C#, IonPython, you have to have the C# on your machine. And after that, if you prepare everything, you can just list all available. The PyenV is installing in your home folder, and all versions are isolated from the global Python system and are just put it on the home folder. And if you want to list all available Python versions, you have to use this command. Sometimes there is a need for checkouting the GitHub repo locally just to update the newest version that appeared in community. To install certain version, we are using such command. We can uninstall certain version, and the same command is used for uninstalling environment. To list all available Python versions, we can use this command. And very important thing is that if we want to know where exactly our virtual env is stored, we have to use the pyenv which Python command, because the normal command which Python we will show the shim directory, which is an engine used by the pyenv, and the real path will be shown by this command. Also, we can activate or deactivate the environment by hand, and there is a possibility to set some namespaces in our terminal of availability of the certain version of the Python. The hierarchy of this command is like this. If we want to just test some Python version, we can use the command pyenv shelf and this certain command. We can attach certain version or environment to the directory, and when we switch inside to this directory, we will have our environment. And we can set up the pyenv global, which will be covering the system Python, which is very good. And it will be shown the last in this hierarchy. I will show it in a quick demonstration. So here, this is my pyenv all versions. I have installed MicroPython. I have Miniconda 3. There is also Anaconda for that. This is all versions that are available by pyenv. We have the version of Anaconda and IonPython, JTON, MicroPython, Miniconda, PyPy, and so on, so on. Here, currently, I have my global system is 3.8.2, which is covering my system Python. And for example, when I change my directory to the pipx directory, automatically there is activation of my virtual env. If I, for example, want to test the MicroPython, I'm using the shell command, which will be covering the environment from the directory and my global Python. And if I just stop testing, I can unset it, and I will be back for my global Python. So this is very convenient during development. I very recommend to use that. And actually, that was the last slide of the second part of pyenv. Then we are now switching for package manager, which is a big topic and big confusion in Python community, because there is a lot of choices that we can make during before we start our project. And here I start with my short story about dependency hell. In one of my projects, I have many libraries. Each of these libraries have many dependencies, and most of these libraries was using the same dependencies, but in different version. In our project, we are using the pip package manager, and we were using the requirements txt file for reproducibility of the of the environment. And after a few execution, we noticed that sometimes our application is not working because of the wrong dependency version, and we were just wondering why it's happening. And we noticed that in some cases, the order in requirements txt was changing our dependency, because the first library, for example, was using the Python, the library version 1.00, and the second one was using 1.03. And what was happening, the pip was not, it's not resolving this dependency versions. It's just installing the first version. In the second line, it's uninstalling this first version, and it's installing again the second version. So we just wanted to know how we can just manage that, and we switched for different package manager, and I will show you plenty of them. But before that, the short story, what was first. In the beginning of Python, we have easy install, which was using X for installing. It was provided with setup tools in 2004. It was using installing packages and its dependencies. And there was no PEP for the easy install. So with the standardization, the pip came across, and we find that and the pip was released in 2008. It's using wheels or source code, and introduced the requirements txt for freezing our environment and knowing what we have exactly installed in our virtual environments. The good news is that from certain versions of pip, the latest versions of pip, there is a possibility of checking the hashes of the versions of Python, so we have more security. But it has to be explicitly used. But as I mentioned, pip is not resolving dependencies. So here is a package, here is a table that is comparing easy install together with the pip. The main difference is that easy install is using X. There was possibility to install the many versions of certain library. There is no PEP for easy install. And for pip, of course, there is PEP 438. It is using wheels. And this is the main, actually the main differences between them. So we have, but as I mentioned, there is still a problem with difference with the resolving of dependencies. So okay. Oh, I'm just moving forward. That's happening. Okay. So before I move to this tool, to these tools, I will tell a short introduction to setup PyScript, which is used for our packages and libraries that we want to install in our environment. We are filling necessary informations, and the setup PyScript is providing the possibility of building the packages, distributing them to the PyPy, and installing in our virtual envs. This is the example piece of code of setup Py. where we have the version, description, authors, packages. We can define additional non-Python packages like SVG files or other data. I don't want to focus on the setup py in this presentation. I just wanted to mention it because it's used in the next tool that I will be talking. So the pip tools, it's a package manager that is using two commands, pip compile and pip sync. And it is resolving dependencies in certain way. It is using the setup py and requirements in file for resolving all dependencies. And after that, after compiling, we are getting the requirements txt where we have all resolved environments, all resolved dependencies, and we can reproduce our environment. The second command, pip sync, is checking whether all necessary versions of libraries are installed in our environment, and it's just showing if there is some inconsistency. Here we are requiring 3 files for resolving dependencies. So if we would like, for example, to create it for dev, test, UAT, and prod environments, we have to reproduce requirements in and requirements txt, which is not so convenient. And then we have a different tool that is pipenv. It can manage the virtual environments. If we, for example, is installing something and we have not activated the virtual env, it is automatically activating the random virtual env with the random name and installing it there. But when it's when the virtual env is activated, it is installing in the current virtual env. And it is using the pip file and the pip file log files. And pip file contains 2 sections. In the first section, there are local development packages that are used for creating the project, and the production libraries. And each time we are providing something, it is resolving automatically all necessary dependencies, and it's telling whether there are conflicts that cannot be resolved. For example, one library is requiring the version 2.3, and the second library want dependency that will require version below 2. So this is very useful tool for pointing out such situations. And of course, when we have the stable environment, we just locking the environment, which then the pip file log is used just simply for installing on our CI/CDs, on Docker images, and so on, so on. Also, pipenv is using our hashes. So we have the security, and there is an alternative for pipenv, which is also great, which is poetry. We use it for actually, the poetry has the same features as pipenv, but it's faster. I will show that. It's faster in resolving dependencies. The main, so it is managing the different environments. It's also installing packages. It's resolving dependencies. But there is also the convenient way of creating packages and publishing into the PyPy. So it is more useful for libraries. And I will say a few words about package manager that is not used, that is not pure Python, which is Anaconda, which is the Python libraries plus some other data scientist libraries. The Miniconda is the smaller version of Anaconda, and the Conda is the package manager. The main problem with Anaconda is that it's not supporting PyPy, it's supporting only their channels. They have different standards for their packages, so there is no compatibility between PyPy and channels, Conda channels, and of course, Conda packages not working with Python virtual enums. So be aware of that. If it is mainly used for machine learning projects, and we have the possibility to use Conda itself or Conda with other package manager. If we use Conda alone, we have to know that channels, we have to choose good channel because very often libraries are out of dated. They are maintained by different people. And most safe is to use Conda with other package manager. Conda for some non-Python packages and Python package manager for getting the latest libraries from Python. And this is mainly useful for machine learning. Also recently, there was a release of a PDM package manager, which is implementing PEP 582. The PEP 582 is talking about storing the libraries inside the project. There is no need for the virtual enums. Everything is with the project directory, and also it's implementing PEP 517, which is installing libraries from the directory. So this is a great feature, but it's on early stages. And finally, we can use sometimes the pipx, which actually is not resolving the dependencies. It's installing one package per environment. And if you want to install a second package, it is installing in different in virtualenv. And also there is a possibility to install two packages in the same environment, but it will finish with not resolving the dependency. So it is resolving dependency because it's installing on one package. So here, I've just gathered all information that I have already said. You can check it. It is separated in 3 tables and annotations to these tables. I will skip that. This is just the reference. And finally, I've made some benchmark. And surprisingly, Poetry is the fastest from chosen package manager by me, and I'm very often using it because of that. And finally, I will tell a few words about my setup. I'm mainly installing pip locally on my home folder. It's not, if I something install from my user, it's installing locally on my Linux system. Then I'm installing pip and Poetry and other tools that I'm requiring for most of the projects that are common for projects. And then I'm installing Pyenv for managing many Python versions and virtualenv. And then I start project by creating virtualenv and developing. So here are all resources that I used for presentation. Feel free to see everything what I used for this presentation, and that's the end of my presentation. Feel free to ask me questions.
Thank you, Michal. See, people loved your talk. See those claps. So okay, so we got 2 minutes. I think I can only go through 1 or 2 questions. So Matthew is asking, how did Wheels help you solve your problem with Terraform and AWS?
Actually, we just had to create a Docker. Docker image that was common for every developer, and we solved that. And then we created AWS layers, where we have all libraries.
Right, okay. Oliver is asking, how is Pyenv in comparison to virtualenv? Any preference and why?
I love to use Pyenv because I can easily switch between versions. I currently working in a project where I have 5 repositories and 5 different Python versions. I don't have to install it in different, I don't have to it install globally, and I just can switch it easily.
Okay. What's the best way to maintain package versions between requirements.txt, pip file, and setup.py?
Could you repeat?
So what's the best way to maintain package versions between requirements, pip file, and setup.py?
I think I'm commonly using the pip file log or poetry log because it's resolving my dependencies. Pip tools is okay, but it's too big to have many requirements for many environments, I think. I don't know whether I answered your question, but we can talk. We can talk after on the next.
Cool. So we reached the end of the time. There's still 3 questions here. I will urge people to have questions to go to the talk on Discord, the channel of this talk. Thanks for coming, and thanks, Mihai, for the talk. We're going for a short break now.
Thanks.
So bye-bye.
Bye.
Hello, James. Hello, James. You ready? Hello, James. Oh, you're muted, but I guess you said hello. you're still muted.
I'm sorry.
Oh, gotcha.
Gotcha. Okay,
Wait,
cool.
So we still got a few minutes. Where are you zooming from?
From Malaysia.
Nice, nice. How's the weather over there?
Weather is complex, I would say. Reason for being, we have a sunny day in the morning and we got quite a big rainy in the afternoon.
Oh, right. So I guess you can make plans for the morning and plans for the afternoon.
Yeah, kind of. But whenever it rains, it affects the traffic. So you got quite a big traffic jams during the raining day. So it wasn't really good. And you got a surprise flood as well.
Oh.
Yeah.
Yeah.
So this is why. So technically, rainy day is kind of a mixed feeling for us. It's kind of good. Sometimes it's not quite good. So it depends.
Okay. Are you ready to present them?
Sure. Let me just share my stuff.
Starts to sharing the screen.
Okay, cool.
And you're gonna talk to us about Android with Python, right?
Yes. Yes.
Cool.
Okay. Here, let me share this. Okay, cool. So we got it here, Android. So the title will be Honey, there's a Python in my Android phone.
All right, so join me in clapping for James.
Thank you. Okay, so today I'll be presenting as the title that I have, Honey, there's a Python in my Android phone. Now, what am I going to share over here on this thing? Okay, so first thing I'd like to talk about the title. So title probably, I don't think quite numbers of you might heard of this movie. It was a very old movie. This took the titles come from here, Honey, I Shrunk the Kids, which is a movie in 1989. I remember I watched that when I was 9 or 10, can't remember it, but I like this movie. And it got 1 and 2. So if you happen to know this movie, yeah, and please watch that again. I still like this movie because it talks about a scientist who shrunk the family's member, and there's a lot of interesting things that happens within the movie. Okay, so what's my thought about today? So my thought today about is we're trying to look at what's happening over the 20 years, especially on the computing powers that we have. Now, if you look at the left one, 486 DX4, probably not many of you will know that that was actually my first computer. So if you compare the specs of this computer, 20 years ago, it was the best or probably the most powerful computers in town at that time, which is I think 1994. And not to mention that if you look at the specs right now, it's not even comparable to what we have nowadays with a small Android phone. And not to mention that it is very bulky. Think about that. The dimension is about 50 centimeters to 50 centimeters. But compared to our phone today, what we got is a pocket size. And for us, during the time in 1994, we have only those 6.22 together with Windows 3.11, which I think hardly got people hear of that nowadays, unless you are a vintage user or you try to play around with all this retro computing, probably you heard of it. And for now, compared back to Android, what we have is Android is so powerful, it can run all the applications that we know, anything, like from Facebook, YouTube, or anything that you have, okay? So compared to the size of what we have now and compared to back 20 years back, the power, the computing power has changed so much that we can't even think of it, and not to mention the size. However, there's a dilemma that we face nowadays with Android phones, because Android phone is not just an Android phone. It is also a computer, and not to mention that it is also a tracker. So you have all sort of trackers on your phone, be it to be your weather, be it to be your behavior, be it to be your usage, or the app that you use, everything. Yes, it's a tracker by itself. And not to mention that on average, you change your phones for every 2 years. So automatically, in some ways, your phones will get lag after 2 years. So how are we going to deal with the phones? Or in other words, how are we going to handle the phones after 2 years? Well, possibly what we're going to do that is we're going to throw away, not going to use it anymore. We'll just throw it away. Or maybe we'll just keep it in some darkest corner. Like what we have, for my case, I have 3 phones in my drawer, which never been used, but still in quite good condition. Or perhaps some of you might want to use it again, like use it for a GPS application. Like let's say Waze, you want to use it because you just simply don't want to throw the phones away. Or some of them might just give it to parents, like parents, they might just want to use an old phone. But the key things that we are focusing on this thing over that is, can we actually program an Android phone? As in program means we can write a simple programs, like maybe a basic, or in this case, Python, or maybe Perl or Shell, any simple programming language that we have on Android phone. However, sadly, what we have for the Android phone currently, the available programming language will be Java-based or Kotlin, or not to mention that the latest one will be Dart, Flutter, or C#. So for me, I find that this is not quite cool. Reason for that is, to me, I find that Java or Kotlin has quite a high learning curve for us. Imagine that when you try to build an app, okay, you need to have quite numbers of skills, ranging from building the interface, writing the backend in Java, and so forth. So it turns out to be quite a difficult way for us to enjoy the fun of the programming. Like maybe we just want to run a small software or programs like in BASIC or Python on the phone. And not to mention that again, if you're trying to install OSs other than Android, it'll be very difficult. For example, think about that. If let's say you want to install OpenBSD or FreeBSD on an Android phone, I think that will be nearly impossible. Or not to mention that you try to install maybe Linux on it. It can be done, but it might be quite impossible or quite challenging to do so. So can we actually do a programming, or maybe let's say Python on an Android phone? So these are the comments that I got when I talk to people about having a Python on an Android phone. The first would be, are you serious? Are you serious about that? Or second one would be, can you actually do that? And the third one, I got a comment actually from one of the guys when I visit Hong Kong that time, and he mentioned that, well, this is funny. We can't really, if you can do that, that would be interesting for us to know. Okay, so this is kind of comment that we got from that. Now, having spoken for so much, I haven't really introduced myself. My name is James. I'm the chair for PyCon Malaysia. And by the way, just to let you have a look at my T-shirt. We have a logo over there. This is my T-shirt for 2019. We have a T-shirt over there. Okay, and I was the chair for PyCon Malaysia 2019. I was the co-chair for PyCon Malaysia 2018. And currently I'm working in an insurance company as a senior automation engineer. And the most important thing that I would like to bring on behalf of my chair for PyCon, we call it PyCon APAC 2020 chair, is we are going to launch PyCon APAC 2020 online in September, so do check out our website. And not to mention that Guido is also joining our conference as well. So do check out our website. So the exact date will be from 13 to 16 September. So do check the updates from our website. Now let's get back to what we know about Python before we jump into Android. So for present state of Python, we know that Python actually can do a lot of things. So for example, we can actually build a simple script for system administration. And that was my background before that. We can also build a web app easily by Django or Flask, or not to mention that we can write the backend as well using the Python as well. And of course, the most important thing is we can write a very simple interaction script on RPI, a Raspberry Pi, through the GPIO pins that, for their libraries. So of course, you know that their libraries are written in Python. So it is very easy for us to interact with that. And this is why it makes the Raspberry Pi so popular among all the, nearly all of those who programs with Python. And of course, MicroPython turned out also one of the key focus for us to write a very simple programs for the embedded systems such as ESP32, ESP822, Microbit, you name it, and everything that can be written in MicroPython. So we actually can do a lot of things with Python nowadays based on what we know. But in terms of having a Python on Android, we don't have much of the choice except from getting an app that runs with Python interpreter. By means, when I say this, Python interpreter, meaning that you had an app that runs Python interpreter on it. It is not something that like Raspberry Pi, where you have something that allows you to interact with the API, okay? Or in other words, interact with the sensors that you have for a phone. For example, gyroscope, for example, the accelerometer, other sensors like GPS, or perhaps let's say API that allows you to make a phone call. We hardly have that, okay? So probably there's one there over there, which that will be the focus of my talk today, which I'm going to show that how we actually can do that. Okay, so that is one thing. Okay, so yes, the answers for that is we actually have access on that Python, but sadly we don't have much of the application on that. So probably the question that you'd like to ask me on that is, how actually can we do that? Or what kind of apps that allows us to do that? So the motivation I have to start with this project actually start from 4 years back, where I'm actually quite boring during my Christmas week, where I'm thinking of cataloging my book. As you can see, the books I have right now at the back. So that was something that motivates me to do so. So when I look at my phone, my old phone, as I mentioned before, I have a few phones in my drawer. I would like to think of, okay, is it possible to allow me to use that phone to build a barcode scanner to scan the ISBN barcode, and then it allows me to insert my book into my DB. So now with the database, okay? That was something that I have in my thought. Is it possible for me to do so? Because, you know, a phone allows us to scan the barcode easily. And not to mention that if you download the app, it can simply just scan the barcode and it returns you some kind of ISBN 39 number if you are boot lover. So this is my motivation. How can I do that? So I begin to start my Google and then search. And then I find that somebody did that before. And the first line of the search actually interests me. Android barcode scanner in 6 lines of Python code. So I begin to wonder, how actually can you do that? Okay, how actually can you do that? So what kind of app that you use from that? So I decided to visit the dig more, okay? And I found that actually there's two kind of app at that time, 2016, where first app is called Android Scripting Environment, and another one is a derivative of it is, or also you call it variants of it is a scripting language for Android. Both are actually, the first one actually is the first version of Google project, and then the other one, if I do not remember wrongly, is the second version of the, or probably you can say it's an enhanced version of the Android scripting environment. So what makes me interested with this project is that based on what I searched from Wikipedia, I found that actually it mentioned that this apps allows us to access the script, access these sensors from for the Android with a very simple script like Perl, like shell script, and of course in this case that will be Python. So this interests me. So I begin to look at the code of this markers and realize that the coding is very simple. So just 6 lines of code, and then you scan it and it returns the ISBN, and you use that ISBN to look for the books from Google. So simple enough. So this allows us to build an app, and together with my student at that time, Vincent Liu, so we decided to come up with a script that allows us to scan a book ISBN number. And the script is named Snapbook because at that time, Snapchat was quite popular. So we decided to come up with a very cool name called Snapchat. And the Snapchat is currently still running. It's still on my phone. And currently I'm still using Snapbook to snap my books for my collection. Okay, so this is the kind of thing. So if you want to know some personal story about the Snapbook, you can reach out to me in the channels, and then I can share you more about this Snapbook story. Okay, basically I still have the code for that. Okay, so after the Snapbooks, I find that a phone with so much sensors over there, it shouldn't be just used only for barcode scanning, since we are allowed to access so many sensors over there. So I decided to dig more further. Okay, I decided to look at more further. I'll say, oh, okay, what can we see? So first thing that interests me is because of the accelerometer. So I decided to go further and write a simple script that allows me to get an accelerometer. So in this case, when I measure that, well, indeed, it's kind of close to 9.81, which normally what we know is about the accelerations of the gravitational acceleration, 9.81 meter per second. Okay, so it's indeed very accurate in this case. So another question that pops up after I wrote the script is that I begin to wonder how Python's actually in that app allows me to access the Android API. And of course, another question is, if we write down that accelerometer and measures the acceleration of the gravity, how accurate or how precise the return data from that API? Okay, so I begin to look at that. When you look back to the script that I have previously, okay, there's 2 files, or perhaps there's 2 modules that allows us to look at it, which is Android helper.py and then Android.py. So let's just look at dissect of the Android helper. So for this class, let's focus one thing because they have a lot of things over there. So let's focus on one scan barcodes method over there. So for this scan barcode method over there, there's one interesting line over there, return.rpc scan barcode. Okay, now this is interesting. Return RPC, interesting. So I begin to look at another file, which is android.py. So I'd like to know, where does this RPC comes from? So when I look at this in details, there's much more interesting information that I can find from here. First thing, it passes the JSON data that we know from here through the socket. Okay, this is one thing. So in other words, it means that actually for Python script to talk to the Android API is through the socket. They pass the JSON through the socket, and there's another socket at the Android end that allows it to pass all the data in JSON form and then returns the API. So that's quite interesting. And of course, on the Android app, this is very simple because in this case, when we send the JSON data over, it will just activate, or you can say that initiate the intent for scan barcode. So from that, it will return the result that it scans from the barcode and it returns the data back to the channel. So as a conclusion, what we have over there is my Python script. Let's say I write a Python script. I'll send this my request or my data, my method as a data in JSON form through Android helper as RPC, and then through the Android. And once Android receive the request in data in JSON format, and then it process to read the data from the sensor. Once it got the data from the sensor, and then the same path, it goes back to this cycles, and then this is how we got the data from the Python script. So what kind of APIs that we have for that? As I mentioned, we have accelerometer, gyroscope, location, Wi-Fi, Bluetooth, SMS, phone call, and you name it. Okay. So there's interesting about here, which is there's two Python's the app that I actually recommend from that, and the one that we have is EuroPython. EuroPython is very interesting, and basically you get two versions that you can download. One is from the Google App Store, and the other one is from the GitHub website. And if you want to have a hacker version where it allows you to access all the Android's API, I recommend you to download it from the GitHub. So you can just go to Google EuroPython 3, and then you can search for the GitHub from that. So pretty much you can get the thing from that. Okay, so what can we do with EuroPython in this case? Since we mentioned that EuroPython is nearly the only app that I know that allows me to access the Android API. So for that, EuroPython it currently runs at the last one is 2.7 and 3.6. Of course, Snapcode is based on 2.5 and 2.6, which is written earlier ago. Then the only things that probably we start from this EuroPython is simple: import Android helper, and that's how we start from that. And by the word, the Chinese word over here means is for larger. It means that for every mouse that you move, it always starts from the first step. So everything starts from the first step. Import Android helper is the first step. Now, the next slide that I'm going to show you over here is the traffic logger that I got from while I'm driving to my office. That was before the COVID time, as I want to try out for my application for that. So this is how I drive. I drove all the way from this, and each point, all these points are actually a point that I plot based on the data that I got from my phone. Okay, so this is how. So the way that I'm doing, I did that was I have my laptop together with me, and have my laptop collecting the data from my phone, and then process it, and then I plot it using a leaflet over here. So pretty much that's how I do it. Okay, so right now I'm going to have a little bit of demo time. Okay, just allows me a little bit of time to show that. And first thing, this is one thing that I'll show you from okay, which is thank you. Okay, so okay, just allows me to do this. It works. Oops. Oops, some problems. Wrong errors. Strange. Okay, never mind. Just give me a little bit of time. Okay, that's interesting. Okay, never mind. I'll show you another one. Okay, so this is my leaflet place. Okay, so right now this is my location, which is near to my house. Okay, so I'm going to get the location, So this is my house actually, previously my point. And then right now I'm going to get the live GPS information for my phone. Okay, some problems with that. Not too sure what's going on. That's interesting. Okay. Yep. Okay, got it. Okay. So this is right now the GPS location compared to the one that I have over here. Okay. So if you can see, this is the real data that I got from that, and you can also get the GPS as well as the locations. So if you look at that, this is point from the EuroPython as well. So right now allows me to demonstrate with another one. Okay, so I hope this works. Okay, yes, got it, good. Okay, so if you look at that, this one, I just need a little bit, refresh it. Yeah, so if you look at that right now, if I turn my phone around, okay, but of course my phone is not quite sensitive nowadays because I dropped it so many times. Okay, so if I rotate this guy over there, so this is kind of the real data or real-time data that I got from the phone. So it will rotate according to what I move. Okay, if I rotate that, let's do it slowly. Do it slowly again. So this is how I rotate and move around with this phone. Okay. Yep. So this is how it works from that. Now, of course, I do not have the time for the SMS. So this is why I use another one, which is GPS, to represent that. Okay. So these are the reference. If you like to interested, you can look at more reference for the EuroPython and all the others Android as well. With that, I'd like to ask questions. And thank you for the talk for today.
Thank you, James.
Any questions from the floor? Any questions?
So I forgot to mention that feel free to use the Q&A setting on Zoom. So far, we don't have any questions. We still have 4 minutes to go.
Okay, so yeah, so if that is the case, then 4 minutes, I would like to use that to, promote my event, PyCon APAC Online 2020. So as I mentioned before, it will be on the 13th of September to 16th of September. So that's first thing. And currently it's online, and we're going to start our ticket sales hopefully by next week. We still have some technicalities that to handle with. And for this time, this PyCon APAC 2020 is a little bit different compared to other PyCon. Reason for that is we have a lot of different varieties of the activities we did. So not to mention that we have the hackathon first thing. We have the hackathon, we have the tutorial, and we do have a conference, and we have panel discussion this time. Because we find that throughout the panel discussion, we can get different kind of people to come to speak to us and to exchange different ideas. So this is one thing that we try for this PyCon APAC online. And also one thing, so same as EuroPython, we did manage to invite Guido to come to us to speak to us. Okay, so that will be a session. So we do have that, and of course, we also managed to invite Keith Parker, if you know that, who's the creator of the snack. Okay, we got him as well, and then we also got Audrey Rowe Greenfield, who's also the author for the Two Scoop of Jungle. So if you know her, and yeah, so these are the few figures that we got for the our PyCon APAC Online 2020 this time. So yep, so do join us. Ticket will start selling, and while current the last update that I remember is the ticket is about $5 USD. Okay, so things might change a little bit, but I'm not so sure. Hopefully we'll still that yeah. So this is kind of my event for that, for the PyCon APAC 2020. Yeah, so my time up, so 2 minutes.
All right. Thanks, James. There's still no questions. If there's any questions, go to the talk channel, which is #talkPython on Android.
So far, I didn't see any questions at the moment. So
no, there are no questions.
Oh, yeah, so, there is a question. Demo effect. Okay. 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 So
no, it's not a question. So I'll move on to the next one. Thanks, James.
Thank you.
For the
Thank you. Thank you. Bye.
Cool. So Ayal, is that how I should pronounce your name?
Almost. It's Ayal.
Ayal.
Yeah.
Oh, okay. There's an R in there. AR. Okay, cool. So where are you zooming from?
From Tel Aviv.
Oh, nice. How's the weather over there?
Shiny and amazing.
Nice, nice. So
we can have coffee. It doesn't matter.
Great. And you're telling us about elegant exception handling, right?
Yeah.
Awesome. Okay.
Can I share the screen?
Yeah, sure. There's still 1 minute still, so you can take it easy.
Cool. So I will click very slowly on the...
Yeah.
Okay.
Perfect. It's
awesome.
Not full screened.
This is the full screen.
Oh, that's the full screen. Okay. Yeah, that's fine. That's fine. We can see. So, all right. So give a big hand for IR.
Hello, everyone. I hope you are all enjoying this amazing conference. I sure am enjoying all the amazing talks. Today, I'm going to speak to you about elegant exception handling. My name is Eyal Travelsi. I know it's hard to pronounce, so my Starbucks name is Jimmy. So about myself, I'm a software engineer at Salesforce. I have big passion for Python and data, and I love to share my knowledge in Medium and on Twitter. So today I'm going to speak about how we can write safe code without compromising over maintainability and readability of the code. So I will show an example of a restaurant recommendation function. As you can see, we have a get restaurant recommendation function. We are extracting the configuration from a path that we are getting. Then we are extracting the user. we are calculating the relevant restaurants, and then we are picking the best ones. So we can be proud of ourselves because we implemented our restaurant recommendation algorithm, and it's clean code and it's highly maintainable. So why should we even care about exception handling? The obvious answer is that errors are everywhere. They can come from hardware, and they will certainly come from your software. And it's simply unacceptable. We want our users to still be able to use our program. So the first lesson that I think you should take is that we should want to build a fault-tolerant system. So we have exceptions for that, and I'm gonna briefly cover the exception anatomy before I'm gonna show you the tricks and tips to write clean code. So exceptions as exception messages, tracebacks, and types. As you can see here, we have the type of the exception, the name error, we have the descriptive message, and we have the traceback, which allows us to understand from where the exception was propagated from which line and from which function. I will delve a bit more on exception types. So exception types help us distinguish between different exceptions, whether it's file not found exception or a syntax error when our code is not syntactically correct. They are hierarchical in nature. There are dozens of built-in exceptions, and if they are not enough for us, we can create our own custom exceptions. So this is not the full list of the built-in exceptions. As you can see, it's hierarchical. We have in the top of the pyramid base exceptions, and we have many exceptions like syntax error and so on. You don't need to remember all of these, but the common ones you probably should. So let's take the naive approach for exception handling. We are basically gonna catch all the exceptions because we are catching base exception, which is in the top of the pyramid. We are then gonna log it away and raise the same exact base exception. So now our code is clean and safe. But obviously, there are problems lurking. Since we catch the base exceptions, we are unintentionally catching many exceptions we didn't expect. For example, most programmers want their code to be at least syntactically correct. And obviously, we are catching it instead of raising syntax error. In addition, exceptions are not distinguishable because we raise base exception no matter what. So if I'm gonna try to recover from the invoker of the function, it will be hard for me to detect whether it was because of a missing file or because of a syntax issue. And unfortunately, the naive code is very, very common. So we understand that the naive approach for exception handling won't be enough for us. So let's take the second try. So instead of catching the base exception, we are gonna catch a specific exception. We're gonna catch file not found exception, JSON decode error, and key error. If I'm gonna catch a file not found exception and JSON decode error, I'm gonna raise the same exact error. So here I'm gonna raise file not found exception and here JSON decode error. And when I have a key error, I'm gonna use a default user as a recovery mechanism. So just by doing so, the invoker of this function can recover from file not found exception and JSON decode error in a different manner. So the second lesson is we should catch relevant exceptions only, and that different propagated exceptions should be distinguishable. This will make our code much safer than the naive approach. But can we make it a little bit cleaner? And obviously, the answer is yes. So in this talk, I'm not gonna cover all the type of cleaning that can be done. I'm not gonna cover PEP8, object-oriented programming, and so forth. But let's begin, and I will show you some useful techniques. So in our example, both the file not found exception and JSON decode error are handled in the same manner, which means they can share the same exception block. In addition, instead of key error, I can use dictionary get method. And by doing it so, I'm avoiding another few lines. Lastly, I can use the else clause, which occur only if no exception is being propagated. And by that, I know that the exceptions can only occur in this function. So this is a bit cleaner than the previous code. And that teaches us that we should use Python syntax to the fullest. But obviously, our code is still not elegant. It's dominated by exception handling, and the business logic is not clear. And we should really try to make it clearer in order for the code to be maintainable. So I don't want you to give up. I really believe that error handling should not obscure our business logic, and I will show you what we can do further to get there. So we should separate the business logic from the exception handling code, and we can do it by handling the exceptions in another layer. So I will remind you how the perfect code look like, and I will show you how we can reach something similar to it. So as you can see, we have the get restaurant recommendation function, and we have the get config function. So if I want to make this part of code cleaner, the business logic, I can simply push the exception handling code to a different place. And by that, I'm making the business logic much cleaner. So obviously the recovery mechanism depend on the use case. Here specifically, I put it in the get config function. And if I want to make it a bit further clean, I can make the get config to a get user function, doing something like this. So obviously, this is much cleaner without compromising on the safety of the code. So we should really try to pick the right abstraction level to handle the exceptions. But are we completely safe? We have some exception handling code, and the code is quite clean. Obviously, we are still not completely safe because we have silent errors. And silent errors are errors that do not crash our code, but they do deliver incorrect results, which make them harder to detect and make them much worse. So the question is, how can we detect those errors? And the answer is simply by using validations. We have many types of validations that we can check. We have output and input type and values. We have preconditions and postconditions, side effects, and invariants. And when we find an issue with the code, when we validate and fail, we should simply fail fast. So we won't find the issue later on. So I'm gonna briefly cover some techniques for validations. We can use vanilla exceptions, we can use type-ins, and we can use contract testing libraries. Obviously, the best solution is to combine all of these depending on the use case. So vanilla exceptions will look something as follows. We have our function and we are adding an if clause that validates the type of the input and the type of the output and raise a type error if the error occur. In addition, I could have checked if it's a valid S3 path, and by that, raising a value error. So obviously, we can validate everything with vanilla exceptions. Those validation will occur only on runtime and not on compile time. And unfortunately, it's not the cleanest code. So I'm gonna briefly speak why I didn't use assertion ears. here because it would save me a one-liner. And basically because it raises the wrong exception type. No matter what the issue is, we're gonna raise an assertion error, which will make our life much harder to recover. So it will be hard for me to understand if the issue was a type error or a value error, for example. Another small issue is that they can be compiled away. The second technique is type-ins. So this is an example for the same code. As you can see, simply I can add type-ins, which tells which type the input is and which type the output is. And just by doing that, we can validate the input and output type, but we can do other validations. We can check it both on compile time using NumPy, MyPy, and on runtime using this decorator, the type checked of TypeGuard library. And this is quite elegant. Another technique is contract testing libraries. As you can see, it's pretty similar to the previous slide. I can validate if it's a valid S3 path just by using this decorator. So obviously, all the validations are supported. They occur only on runtime and not compile time. It's clean and elegant, but unfortunately, to my knowledge, there is no mature and maintained option for contract testing library. So you should be really careful when you pick your own solution. But there are still problems lurking around. Even for a simple function like the get relevant restaurant, which basically do a get request to an imaginary URL, there are a lot of exceptions that can occur. So our app might live in an unstable environment. And by that, I mean that my network can be down, the server network can be down, the server can be too busy, and many more issues. So one technique to make our code more resilient to flaky environment is to do a retry mechanism. So here is a naive implementation of retry mechanism. Simply, I'm going to iterate 5 times on the same request. And if I'm getting an exception that is corresponding to a flaky environment, I'm going to retry unless I reach the maximum allowed retries. So obviously, this is much safer, again, but it's not clean and it's obscure our logic. So there must be a better way, and obviously there is. So Python has a lot of patterns that are really common. We have decorators and we have context managers. I'm not gonna cover them too much because it deserves its own talk. But obviously, the most common use cases are already implemented in the standard library or in other third-party libraries. So in our example, we can use the Tenacity library to do a retry mechanism. And by just using external library, we are reducing the amount of bugs and we are getting more features. As you can see, this is much cleaner. So we should use patterns for better code reuse. So what I'm gonna speak about next. So I'm gonna delve a little bit more into exception types. As a reminder, exception types help us distinguish between different exceptions. They help us emphasize our intent, and we have both built-ins and custom exceptions. So I'm gonna speak about when we should use custom exceptions or built-in exceptions. So in my point of view, and it's very controversial topic, the entire slide is that we should use default exceptions by default. Because they are familiar, they are well documented, we can do some Stack Overflow magic with them. But obviously, we have custom exceptions for a reason. And the reason is that sometimes the built-in exceptions does not suffice. And these are the cases. When there is no built-in exceptions that emphasize our intent. For example, if I want to emphasize that I have a configuration file and it's malformed, I might create a malformed exception type as opposed to use some value error. In addition, if I want to distinguish between different exceptions, for example, if I want to recover differently from a value error that is too big and too small, I might create a new exception type. And when I want to group together different exceptions to make recovery easier. So I can use multiple inheritance to make the recovery much cleaner. And lastly, when I'm gonna wrap third-party APIs, and I'm gonna show it in the next slide. So when we are wrapping third-party APIs, we want to minimize our dependency. I'm gonna show you an example here. So let's say I have the getRelevantRestaurant function, which can raise request read timeout. If I want to recover from this function, this means I need to do import of request in this function. So in this case, I know in this function which implementation was used in the getRelevantRestaurant. And if in some case the getRelevantRestaurant will change the implementation, I will need to change my code as well, which is obviously bad. Another cool thing about exception that it has cause. So the exception cause indicate the reason of the exception, and we can override it to replace the exception that is being raised. I will show it. It will be much easier to understand. So let's say we have a zero division, and I'm doing some amazing recovery mechanism, and I'm failing. So by doing so, I can raise the zero division error. But let's say I want to emphasize that my recovery mechanism actually failed. So I can do something as follow. And as you can see, I will have the two tracebacks and two exceptions here. If on the other hand, I just want to show that my amazing recovery mechanism failed, I can do something as follow. And as you can see, I'm raising the exception. Obviously, raising exception like this is a bad practice, and you should pick or create your own custom exception in this case. So we should really strive to pick the right exception type and message to emphasize our intent and to help us recover. A small thing about sensitive information. So our exceptions gonna be spread far and wide. It's gonna be in the logging system, in the monitoring system, in the incident system, and even on Slack. So we should be really careful when we are handling personal data due to many reasons like compliance. And we should never reveal our own weaknesses because there are bad actors everywhere. So you could never be too careful. A fun example for that is that if I'm gonna do a login and I'm failing because of a too common password, I don't expect anyone to write the password in the exception message. There are some common gotchas for exception handling in Python that I'm gonna cover. So exceptions as a block order. And by that, I mean that when an exception is being raised, it's gonna try to match the exception type from top to bottom. By the way, value error is both exception and a value error. So in this specific example, we would expect to get a value error because it's the most specific exception. But obviously, we are getting an exception. So we should write the exceptions from the most specific ones to the more generic ones. Another common gotchas is the not implemented and not implemented error. So not implemented error is a valid Python exception, and not implemented is simply a constant in Python. So when we are raising a not implemented constant, it tells us that it's a type error because we are trying to raise something that is not an exception. It tells us that we should raise something that derives from base exception. As we said, it's in the top of the pyramid. Another gotcha is return in the finally block. So let's say we have this try block, we have some exception handling, and we're returning. So when we see the return, we think we don't need to read further the function. But obviously, we're getting the surprising result. So finally, occur no matter what in the try except block. So you should be really careful when you are returning from the finally. If we would have a return block, it will work in the manner that we thought. And that's about exception handling gotchas. But this sounds like a lot of work. Should I do all of these no matter what type of application do I have? So obviously, not all programs are made equal. We have some programs that need to be extremely reliable, like airplanes and electricity factories. We have systems that we want to be highly reliable, like our driveless cars. We have reliable systems, dodgy systems, and basically crap. So for the first lessons that we learned, we want to build a fault tolerant system to a certain degree, depending on the use case. So let's remind ourselves the lessons. We want to build a fault tolerant system to a certain degree. We should catch relevant exceptions only. We should make different exceptions distinguishable. We should use Python syntax to the fullest. Error handling should not obscure our business logic. We should pick the right abstraction level for handling our exceptions. We should validate and fail fast. We should use patterns for better code reuse. We should pick the right exception types and messages to emphasize our intent and to help us to recover from it. We should not use sensitive information. And there are some exception handling gotchas. So there are some topics that I didn't cover, error codes and when we should use error codes as opposed to exceptions, the functional approach for exception handling and its benefits, how we can avoid some error using domain-driven designs, and architectural patterns for resiliency. So feel free to ask any questions now or later. And I hope you enjoy the rest of the amazing talks in this amazing conference. Thank you.
Thank you for the talk. All right, so we got a question here. When you recommended earlier to use the built-in exceptions when possible, and so like, what are the advantages of using one of the custom exceptions instead of one of our specific ones?
So I briefly covered it. Obviously, if I want to recover, I will give you an example. So let's say I am an account manager and I can only work on companies that are between 100 and 200 people. So if it's bigger, I might move it to a different team. And if it's smaller, I might just ignore this customer. So basically, if I want to distinguish between different exceptions, this is one reason that I would pick to create a custom exception. Another one is third-party APIs that I showed. And lastly, if I want to emphasize my intent. So if I want to emphasize that my config file is malformed, I can't use any of the built-in exception because it's very specific.
Right, cool, thank you. Is the iContract package reliable for production? John asks.
So probably not. What I do specifically is just to write my own decorator because the iContract is not, it's not very stable and mature, unfortunately. If any one of you know about contract testing library that is more mature and more stable, please share it with me. But as I said, it's pretty easy to just write this specific decorator and just simply use it.
All right, thank you very much. Those are all the questions that we have.
Amazing.
Thank you very much.
Thank you very much.
Okay, so we'll have now a little word from our sponsors.
Hello, I'm Diana, Python developer advocate at Vonage, formerly Nexmo. We're a cloud communications platform and we have an amazing Python SDK. Find out more at developer.nexmo.com and make sure to stop by our booth for a coupon code to start building for free today with our APIs.
Cool. Hello, Olga.
Hello, I am muted myself.
Are you ready for the talk?
I'm very excited.
Nice,
yes.
Nice.
Yeah, today has been nice so far.
Great. How? Where are you zooming from?
I'm currently in London. Yeah,
Cool.
which is surprisingly super sunny today. Yeah.
Yeah, true, true. Okay, do you want to, I mean, there's still 1 minute left, but you can, if you want to start sharing. You're going to talk to us about how to make our Python code more resilient against viruses. Oh. You froze for a bit.
Okay.
Did you?
Yeah, sorry. Can you see me now? Well.
Yeah. It's okay now.
Okay. Hopefully we won't have more of this. Okay.
So,
can you see my screen?
Yes. Okay. Cool.
Okay.
Now it's
excellent.
all good. So, Olga, tell us about social distancing from our dependencies.
Yeah. Okay. Thank you for the introduction. I'm very happy to be here, and today I'm going to be talking about a timely matter. Since we have spent, all of us, a few months applying physical social distancing, we can discuss today how we can use those techniques to make our systems a bit more reliable, isolating our dependencies from them. Before I begin, let me introduce myself. My name is Olga Matuda, and I come from sunny Greece, while I currently reside in, as I said, very sunny London. Surprisingly, this week has been very nice. I studied electrical engineering, but then software won my heart. And I enjoy immersing myself into risky activities, be it public speaking, dancing with other people, or trying new recipes. Nowadays, I work at Bloomberg as a software engineer, and I spend a lot of my time in my team debugging C++ code. We do write some Python code as well. We have mostly used Python as a tool for writing scripts to quickly achieve something, or for integration or end-to-end testing. But last year we had a crazy idea. How about we use Python for a real service? We wanted to do something simple, and we said Python, it is a good opportunity for us to try using Python for something real that we can use in production. So that is what I'm selling today. This is a story of a Python service written by C++ developers. And I promise you it's not a horror story, but it's a story of success and many, many learnings. As I said, we have mainly been using C++ in the past, and we have used Python for simple applications. And this is how we tend to use Python. So, and this is how we envisioned our new service is going to look like. There's going to be one function. We don't really need more. We're going to have an input. We're going to do the stuff we need, and we're going to have our output there. How hard could that be? It turned out it wasn't that hard. That was, we wrote some completely valid code that looks a bit like what you see on that screen. And we thought that we were ready, everything seemed to be working. And we had a meeting with our product manager, Mark, and he said, is this ready to go to production? And that is where we asked ourselves, okay, maybe we can be safe as we do with all our other services. It's time to write some tests. Yeah, what could possibly go wrong with Python? But okay, let's write some tests. And that is when we realized that that wasn't as easy as we had imagined previously. We didn't really know how to write unit tests in Python. We had written an integration system test before, but unit testing was something new for us. We tried writing some, but we had a dependency that ended up misbehaving in the dev environment. So our tests could fail randomly. Meaning that our constant continuous integration platform would complain a lot, meaning that we would have many emails, meaning that there was no real automation that we could apply further because everyone was very annoyed. And everyone was super, super sad due to that. And we knew it was time to take this a bit more seriously. It was a small project, but again, we had to apply the same good principles that we applied as in any other project. And since we had an unstable dependency, we knew that we had to isolate our environment from it. We had to somehow mock it and make our tests not directly dependent to that. So this is a sort of physical distancing from that unstable dependency. As I cannot get into much detail about that specific project, today I'm going to be using another example. Let's say that we want to create an application that gets movies from that are currently playing in theaters, like in normal times. And we want to rate those movies based on a very random metric that we have. And that is based on the director of the movie. We want to send back to that API a rating. So let's say that every movie that is directed by Quentin Tarantino gets a 10, and every other movie gets a 3. This is our great movie application by Get and Rate Movies. Yes, I laugh at my own jokes. And let's start with a simple version of that. Here it's an example of an application that uses the movie database API. That is a free API that you can use for your personal projects. And we send one GET request to retrieve all the movies that are currently playing at theaters. So we use the request module, we send that GET request, we get back hopefully a good response, and we put it in a nice dictionary and we return it. That is all that we have to do for now. And as Mark is really impatient and wants it to production, we need to write tests and make sure that it works fine. And this is how a test for this application would look like. We are using the unitest.mock module and we want to mock the path that sends that request to retrieve the movies that are currently playing. Above, you can see that we are specifying a mock response that can be a much simplified version of what the real API would return. We just return the fields that we are interested in, really. And we have a simplified dictionary retrieved back. That is a very low effort test. At least we don't have much to think about, except maybe for the first one when we are first creating. But this is easily extensible to more tests. We can write more tests where we parameterize, we expect empty results, different responses. We have different side effects when we call that external API. We can expect failures, connectivity issues, and everything else that we can imagine. And that was okay. It was valid code. It was a very valid test. Now let's see what happens when we have a more complete application. This is what we want to achieve in this example. We said that we want to get the movies that are currently playing at theaters. That returns us the movie titles and the director IDs. So we need to send another request to the movie database API to get back the names of those directors. So then we can apply the rating that we were discussing before. So we sent, on the second line, we send another request where we full the movie directors' names. And when we have all of that, let's say we want to do some filtering on all of those movies that we have acquired, because we don't want to get busted from that API and that we send ratings for all their movies. We want to send only to some of them. So we're using another, let's say, in-house API, the Magic API. And first we do a request to that to do some filtering of those movies. Once we do that, we have a filtered movies dictionary. And for each movie that exists there, we want to apply the magic algorithm that we have created that decides the rating according to the director of its movie. And then we want to do a post request in the movie database API, posting the calculated rating we have. In the end, we can just return the dictionaries and save them in database or what we want to do, log them, whatever. That means that for this simple application, we have five different calls into external APIs. 3 of them go to the movie database API, 2 of them go to the Magic API that we have created. This seems to be completely valid code, does everything that we want. We have our separate functions, and yeah, all seems good. What happens when we want to test it? We patch it up, right? And then philosophical questions arise. How many context managers can you fit in 88 line characters? If we need to mock those 5 different API calls. And I have very strong opinions on styling, and that's made my life very hard. Thankfully, we can use a decorator, so that would mean that our tests are gonna look something like this. We can have, yeah, I couldn't even attempt using context managers, so decorators to the rescue. We have 4 different decorators that we need to carry with us in each test that we're going to write. The first one actually needs to be parameterized because we do 2 GET requests in the movie database API, depending on the exact request that is called. And as you can see, this is already a lot. We need to write more tests, and we need to carry all of this with us every time. So that test was okay, but what happens? It was okay, but what happens when we want to write more tests? What about when we have different arguments, other responses, empty responses, other failures and exceptions? In that test, we want to test our application and its business logic. It's not the place really to carry all of these decorators and test the different APIs. Of course, we want to test them that they are called correctly, but do those tests, can these tests even provide us that? So it's easy to mix the business logic with these IO concerns. So because the mocks don't really help with that, we will need to write integration tests. And yeah, that was a lot. It was very easy to forget to move those decorators with you. It was tightly coupled to implementation details. So we had to change our strategy. And as every good developer, when we don't know what to do, we use a search engine and Stack Overflow. And yeah, you use your favorite search engine and you type, how do you write unit tests in Python? And you click on the first result, and someone on Stack Overflow always has a very strong absolute opinion that says, every time you use mock.paths, it means that you have design flaw in your architecture.